HMI Schneider model GHO certified 02 with PLC S7-200 Smart CPU SR30. Before go to create the new program for test, I would like to explain the diagram a little bit. Okay, right now I will use software Step 7 Microwin Smart and WinCC Designer version 6.2 CVPH to create the new project to download to the HMI by using the USB Type B, and I will connect the connector RF485 from PLC S7-200 Smart to HMI port COM2, and the transmission is 9600 for this communication, and I will use LAN cable, create project from the Step 7 Microwin Smart and then download to the PLC Smart by using the Profinet port. Okay, so this is the sample example that we can create the start and stop button and the signal of the output here, and then we can pre-start and stop from the HMI. Okay, so let's go to our software to create a new project for Step 7 Microwin Smart and WinCC Designer version 6.2 to download to HMI and PLC and then test together. So let's go. Okay, so first let's open the Step 7 Microwin Smart. Right now I will use version 2.5. Yes, basically we can create the start and stop button for start and turn on the output. Yes, so let's go. First I will create the button stop, example M0.0. it is the button stop. Yes, we can write as stop BP. Yes, stop push button, and I will use start button M0.1, and we can define the symbol start PB. Yes, and I will turn on the output for SIMATIC S7-200 Smart CPU SR30. There are digital output 8 and plus 4, right? So 12 output. Yes, so I will turn on 12 output, so we can use the Q0.1, sorry, Q0.0. it is the output 0, and we can copy 1 2 3 4 5 6 7 8. Yes, and then we can connect the wire. Yes, and I will hold signal if I push the button start. So I will hold Q0.0 output 1. Yes, so let's change this one to 1, this one to 2, this one to 3, this one to 4, this one to 5, this one to 6, this one to 7. So 0 to 7 it is 8 bits, and then I will create one more button. Yes, we can compile. And then this network I will create one more button. Example, stop PB2. This one I will rename as stop PB. Example, this one I will create M0.2. It is stop PB. Stop PB2. And one more button, M0.3. Stop PB2. Sorry, start PB2. And then I will turn on more output. Yes, here 1 2 3 4. Yes, so it will start from Q1.0. So I will use coil, and then Q1.0, Q1.1, 1.2 and 1.3. This is the last one, right? So I will change this one to 9, change this one to 10, and change this one to 11. Yes, the last one. And I will hold the signal. When I turn on output number 8, yes, and then we can compile the program. Yes, no error occur. And then we will download this program to the PLC. So first let's setting the CPU. Okay, SR30. And then for startup, I will start run the CPU. Okay, and then let's check the communication between our PC and PLC. So let's go to communication and then find the CPU. Okay, 192.168.20.2. Then we can ping. So ping 192.168.20.2. Yes, that's okay. It means that we can connect and communication between our PC to the PLC. Yes, and then we can download. Stop the CPU, and then I will run the CPU back, and we can online. Yes. So if I push start, this output will on, and I push stop, this output will off. Okay. So we will go to create the project of VGO Designer to download to the HMI Slider. Yes. So let's open VGO Designer and then create the new project. Example, PLC S7-200 Smart. Yes, and then click next to continue. And for target name, I will choose S7-200 Smart. Yes, and here is the model that we already installed here. Yes, so if we install the VGO Designer, we will got this model. So right now let's choose the model to connect with the hardware. And right now I will use HMI HGO0 And HGO series, there are 3 types that we can use. Has a HMI HGO 0, HGO 3501, 3502, 5502. Yes. So right now I will use 3502. It is the same as my HMI. It means that here, yes, GHO 3502. Okay. And then click next. And then click next. And here is very important that we must add the driver to the HMI, driver the PLC, yes, otherwise it not work. So let's add the driver. So there are many type of PLC model. Example, ABB automation, immersion process management, generate driver, Mitsubishi, Omron Corporation, Rockwell Automation, Schneider Electric, yes, industrial, Schneider Electric USB accessory, Siemens AG, Toyota Machine Work. Okay, so right now I will use Siemens AG because I connect to the PLC S7-200 Siemens, yes, and then I will choose the SIMATIC S7 MPI/PPI, and then choose the S7-200 series, yes, so click OK. So it's very important, if we choose the incorrect type, it will not work perfectly, yes, so let's choose the correct type and then click finish. It will got the screen, yeah, provide the screen default, and for the screen we can change the color, example this color, or we can change another color that we want, yes, so I will choose the color. And we need to create the push button start and stop, right, for turn on the output. So example, I will choose the push button here, yes. Okay, example, stop PB1, yeah, and here we can choose the font size, yes, example I choose this one, yes, it will got like this. If we choose this size, yes, okay, and if we would like to change the color, we can go to the color and then choose here. Example, I will change to red color, yes, it will go like this. If we would like to change the text color to be black, can also change like this. Okay, and then we can copy for button start PB1. And then we can rename to be start PB1. Maybe we can change the size a little bit because it's so big. So let's go to label and then choose design, yes. this one we can also change the style. Go to label and then choose design. Yes. Okay, and then we can align because we need to put the button. Yeah, so we keep the space for another button for group 2. For start button, I will change to blue color. Okay, and we can design the style that we want. Yeah, it pre-style for designer. Okay, and then I can copy for button for group 2. So I will rename this one to be PB2 and this one also PB2. Okay, and then we need to declare the parameter of the button, right? Yes, because if we not define or declare the function, it will error. Yes, compile not successful. Yes, because the function is not defined. Yes, so we can configure. Example, stop push button 1. Let's see here, it is M0.0, right? M0.1 it is start, M0.0 it is stop. So we can go to push button, and then here we can use bit because we use bit, and here we can choose set reset toggle. Set it means that set forever, reset it means that reset the function, toggle it means that when we push 1 it will hold, we push again it will release, and for momentary on it means that when we push it will on a little bit, and then when we release it will off. And for momentary off, if we push it will release off. Okay, so right now I will use momentary on. If I push one part it will release. Yes, and then let's go to choose the text. Yeah, I will choose new text. Example, stuff PB1, and the data type is Boolean, and then it is the scan group. It means that we connect to device of PLC S7-200 Smart. For device address we can choose here and choose %M. So for stop M0.0, right? So it correct. Okay, like this. And for start is the same function. We can go to source and then choose bit, and I will use the momentary on also because I need, if I turn on push it will turn on, if I release it will turn off. And then go to destination and create a new tag. Example, start PB1, and I will connect to the PLC S7-200 Smart. So I will choose device and then M0.1, right? M0.1 it is start, and then click OK. OK one more time, and OK one more time, and OK one more time. Okay. So we need to configure the group 2 also, right? For group 2, yeah, pull button stop group 2 M0.2, yes. So double click and then go to operation bit, momentary on, destination. I will create new text, example stuff PB2, and it will start from M0.2, right? Okay, okay, one more time. And for start, it will start from M0.3. So bit M0.3, momentary on, and then new text, example start PB2, and address is M0.3, yes. Okay one more time, and then OK one more time. Okay, and we need to show the status of the digital output also, right? Here example, we will show this status, yes. So it will start from Q0.0 until Q0.7, right? So I will choose the text. Example, connect PLC S7-200 Smart with HMI THO 0 3502, right? Okay, and then font size, we can use the font size. It will come like this, or we can use another size. Example, I will choose bold. It will bigger than before. And if we choose another size like this, it will big, yes. And we can adjust. Okay, like this. And we need to show the status of the output, right? So let's check, use the lamp, yes. Example lamp 0, yes. For lamp 0, let's go to the variables here. So for general, we can use the variable here, and for the color, we can use another color that we want. Yeah. Example of color, I will use red color, and on status, I will use green color, and for the type, I will use this one, yes, 02. And for the variable, we can go to create a new example Q0, yeah, and it will start from Q0.0, yes. Okay, like this. And then we can copy for bit number 2, sorry, bit number 1, bit number 2, bit number 3, bit number 4, bit number 5, bit number 6, and bit number 7. And one more for group 2, it is 4 bits more also, so we can copy. Yes. So we can align like this. Okay. And for this one, we can align also. Yes. And then we will configure for bit number 2 here. Example, I will use new and then Q2, sorry, Q1. So Q0.1. This one I will define the new Q3, sorry, Q2, Q0.2, and for the color I will choose the same, yes, the same format with the first. So this one should be Q3, so Q0.3, and this one should be Q4, so Q0.4, and this one Q5, so Q5, and then Q0.5, and this one for Q6, so new Q6, Q0.6, and the last one for group 1, it is Q7. So Q0.7. Okay. And then for group 2, I will start from Q1.0, right? So let's go to color and then choose. This one should be Q8, right? So Q8. And start from Q1.0, yes. Q9. So it will start from Q1.1, Q10, it will start from Q1.2, right? And the last one should be Q10. So Q10. Sorry, this one should be Q11. And then start from Q1.3, right? Okay, so 1.0, 1.1, 1.2 and 1.3. Okay, so totally 12. Yes, 12 bits. And then we can simulation before download the project to the HMI. Yes, or we can adjust the size maybe bigger than this. Okay, like this. We can adjust the size. Okay, we can adjust one by one. Yes, so we can design the style that we want. If everyone would like to design another style, yes, we can design. So I just example, so I will use this style first, and then for this one I will adjust also like this. Yes, adjust like this. Okay, like this. And the last one. Okay, and then we can save and then simulation again. Okay, good. So we can download the project to the HMI. So before download, let's connect the USB Type B to the HMI and PC. Yeah, let me connect. And then I will choose the VMware. Yeah, because right now I use virtual machine. Okay. And we can check the connector if we properly install. We can check here. Yes, we can take out the USB Type B and then insert again. Yeah, and we can check here. Yeah, it is the driver of HMI that we can download. HBTZG 935/USB-B. Okay, it means that USB Type B. So we can go to download here and tick here and then click yes to confirm download. And wait a moment for downloading. Okay, right now it's downloading. Yes. Okay, it download finished, but it doesn't config the baud rate, right? So we need to create the baud rate. Yeah, config the baud rate for COM2. For PLC S7-200, we will use 9600, right? Yes, it's very important. If we choose another baud rate, transmission rate, we cannot communication between HMI and PLC, right? So let's click here 9600 and then download again. Okay, waiting for download again. It will reboot the HMI a little bit during downloading. So don't turn off the power of HMI during downloading, otherwise it will error the HMI. Yes, so be careful. Right now it complete downloading. Yes, and we can take out the USB Type C, sorry, Type B from computer. Yes. So right now we can test together. I will push start. Let's see. The output is turned on for 8 bits for group 1, and for group 2 we can push start. Yes, but the color is incorrect, right? For this one, maybe we can change the address. Yeah, so let me change the address. Bit number 2 of group 1 and number 3, right? So this one should be, oh, this one should be Q10, right? Should be Q10, right? Okay, so choose Q10. And this one should be Q11. This one Q0. I will revise the address again. This one Q0, this one Q1. This one should be Q2. This one should be Q3. This one should be Q4. This one should be Q5. This one should be Q6. And this one should be Q7. And for group 2, this one should be Q8. Okay, it's correct. This one should be Q9. This one should be Q10. And the last one should be Q11. Yes, correct. And then we can save the project again and then download to the HMI again. So I will connect the USB type B again. Okay, when we connect the USB type B, it will ask again. And then I will choose virtual machine. Yes. And make sure we go to check the device manager here. Yeah, this one. It means that we already connected the USB type B cable. So we can download. Yes, download again. Okay, downloading. So wait for downloading. Don't touch anything with the HMI. It will reboot automatically by itself. Yes. So take time a little bit for downloading. Okay, so right now it finished and then we can online here. So let's see Q 0.0 until Q 0.7 is turned on, and Q 1.0 until 1.2 1.3 is turned off. So we can push the button. Yes, tap with me together. Okay, so let's test again. I will start the group 2. Yes, it turned on. Stop the group 1 again. Turn off. So the color is correct. Turn on again. Turn off this one. Turn off this one. Start group 2. Start group 1. Yes. So it worked perfectly between HMI Schneider and PLC S7-200 Smart. Yes. So this is just example about how to link the data from PLC S7-200 Smart to Schneider HMI by using the COM2, yes, and baud rate 9600. Okay, so in this point it's very important. If we choose incorrect baud rate, it doesn't work perfectly, yes. So we must choose the baud rate 9600. Okay, so thank you very much for watching my video. If everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. And I will drop the example project under my video so everyone can download to learn or to use. So for this time I would like to say thank you very much again and see you next videos. Bye bye. I would like to show and share about how to connect the PLC S7-200 Smart CPU SR30 to HMI Schneider model GHO certified 02. This is a reply to a comment on my channel about how to connect with the cable RF485 pin that our fan is comment on the previous video. So today I will detail about how to connect the RF485 cable pin assigned that we can connect from COM2 of HMI to PLC S7-200 Smart. For in this pin we can also use with PLC S7-200 or PLC S7-300 also, yes. And I will use software SIMATIC Step 7 MicroWin Smart version 2.5 and Schneider software Video Designer version 6.2 to create the screen, example screen, and then test with the PLC. Okay, so let's go to see the drawing of assigned pin for communication from the HMI to the PLC. So let's go. So here is the drawing that I already summarized with the pin connection of RF485 cable. So for the PLC side here we use female and we have 9 pins for this female, right? So we need to use the resistance, 3 resistance. The first one is connect with pin number 6 and pin number 3 with the resistance 390 ohm, and we will parallel with the pin number 8, yes, with pin number 8, and then connect to pin number 5 that use resistance 110 ohms, and one more for 390 ohm also. Okay, and for the pin number 5 it is the ground, so we can connect with the resistance, and then we use only 3 cables. The first one is ground cable here, number 5 we connect to number 5 of part of HMI Schneider, and for this pin we use pin number 4 connect with pin number 8 we can building with the cable, yes, small cable with the resistance. Follow my drawing, yes. So number 5 connect with number 5. Number 8 connect with number 2 or number 7, but must parallel with resistance 110 ohms also. And number 3 we connect to number 3 and we can parallel with number 1, yes. Number 2 we can parallel with number 7, and number 6 we can connect directly cable by using the welding to number 9, yes. And we use female for this part or this side. So here we use male and here we use female for connection. So I hope everyone can understand about my drawing. And for the resistance, we not fix only 110 or 390 ohms. So we can use different a little bit. It is no problem. I already test. It work also, yes. So please follow my drawing and then test together so we can send the data or control the logic from our HMI to the PLC by using this connection. Okay. So we can use the small cable to connect to welding with this connection. And for the length of this cable, we can use not over 5 or 6 meters. So for me, I use only 2 or 3 meters, so it works perfectly. Okay. So everyone can test with the 7 meter or 8 meter. If it works, it will perfectly, yes. So let's go to our software to create the logic for test with the connection of this drawing. It means that send from the HMI to control the output of PLC. Okay, so let's go. Okay, so first we will create the sample logic and then create the screen for HMI and then download to the HMI. After that we can test together. Okay, so I will create a new folder to keep the project. Example S7-200 Smart with HMI Schneider. Okay, so let's open the SIMATIC Step 7 Microwin Smart. Yes. So basically we can insert the hardware configuration. I will insert the CPU SR30. Yes, it is my CPU. And one more thing, have the comment on my video in the previous video also. Yes, our friend comment with the how to set up the setting of the CPU. When turn on and turn off the power, it will run automatically run. Basically, we can go to CPU tab and then go to startup tab and choose the run mode. It is 3 options that we can use. The first one is slash, the second one is run, and the third one is stop. If we choose stop like this, it means that when we turn off power and turn on again, the CPU is not run, right? So if we choose run and then download the logic or setting to the PLC, when we power on, it will run. Okay. And for the last The last, it means that it will remember the last condition of the CPU. Example, the last condition is stop. So when we power on and we choose last, it will stop. When we choose run, it will run. Okay, so it means that the last. So for me, I recommend to use run mode. Yes, and then we can connect the LAN cable. Yes, I will connect the LAN cable from my PLC by using the Profinet port. Yes, to my PC, and then go to communication and choose the correct network card that we already installed. Okay, I will choose gigabit network connection. It is the network card of my PC. So it detect 192.168.20.2. Okay, so if we would like to change the IP, this IP, we can use edit, and then we can change it. Yes, change another IP that we want. Yes, but right now I'm not changing the IP. So we need to put the IP address of our PC to be the same rank of PLC. Yes, so I will put 192.168.20 dot something, but not dot 2, right? Because the PLC is dot 2. When we put dot 2, it means that it complete the IP. Yes, so I will put 253. Yes, and push tab keyboard, it will give us with the subnet mark 255.255.255.0. Okay, after that we can click OK, and then we can ping. Yes, ping 192.168.2 .20.2. Yeah, it's so like this. It means that we can connect, or we can communication between our PC with the PLC. Okay, so we can create the sample program for test with our HMI. So the first one, I will use NC M0.0. Sorry, this one should be M0.1. Sorry, M0.1. And I will turn on the output Q0.0. So this one, it is start. So this one, I will put start M1. Sorry, stop M1. We can go to the symbol table, and then we can change stop M1. And this one start M1. Okay, and we can compile. Yes, error 0. And then I will hold the signal by Q0.0. Okay, and then we can save the project. Okay, this one, example PLC project. Okay, and then we can push download to download our logic to the PLC, and we can online. Yes. So we need to create the sample project of the Schneider HMI and then download to the HMI for test, right? So let's go to Open Video Designer version 6.2. Yes. And then we can create a new project. Yes, I will go slowly because easy to everyone can understand. Yes. So push next, I will insert PLC Smart HMI. Yes. Can copy and push next. And here it is the target name. I will put PLC Smart HMI connection. Yes. And we must choose the HMI to match with our hardware. So HMI GHO series. And here is the model number, the same as our slide. Yes. Here. And then go to next. Next again. And we need to add the driver, right? So I will use Siemens AG. And then we can choose the SIMATIC S7 series. Yes, this one. We can use S7-200 series. Yes. And click OK to confirm. And then choose Finish. Yes. It will create the project automatically. Yes. And we need to setting the project, right, to connect with the HMI. So this one should be choose the baud rate. It's very important. If we choose 187500, we can connect with the PLC S7-300. Okay. So right now we will connect with S7-200, right? So we must choose 9600 for transmission speed. Yes. Again, if we would like to connect with PLC S7-300, we can use this baud rate. And if we would like to use the PLC S7-200 or 200 Smart, we can use 9600 for transmission speed, and we will connect to COM2 serial interface RF485. Yes, and then this we can use default. So we can click OK. So this setting is very important. If we choose incorrect setting, we cannot communication. Okay. So first, we need to know how to wiring the connection, and the second, we need to know about how to use the baud rate. Okay. So right now I will choose 9600 for communication. And then we can go to create the variables. Yes. So go to variable. And then the first one, we need to choose the boolean, right, for stop button. So I will choose Boolean, and here we can rename, yes, example stuff M1, and this is a scan group. It means that driver that we already choose, and here is the address. So address we can use M0.0, right? Okay, and the next step we can use Boolean, yeah, add one more Boolean. Example start M1, and the address is M0.1, right? So M0.1, you can choose this one, yes, M0 bit 1, okay? And the next we can use Q0.0 for motor number 1. So we can choose Boolean, example motor 1, and then we can use Q0.0, okay? And we can back to our screen, and screen here we can change the color, another color that we want, yes. So we can go to property, yes. We can go to property, object property, right? Screen 1. And we need to set the download target that we would like to choose. So go to general tab and then download. Here we choose USB. If we choose file system, it means that we can download to the USB plus or some drive that we want to download to our HMI. Okay, so right now I will use USB type B. Okay, so it have one more option. It is very important here. Include editor. It means that when we already create the project and then we choose like this, we can download to the HMI, and then we can upload the project from the HMI back to our PC. Okay, so I recommend to tick this one. Next time we can upload back or back up the project from the HMI, yes. Okay, and then we can go to push button, right? So let's go to switch. Okay, label example stop M1. I will use this font size, yes. It's very big, right? So we can adjust. Okay, stop M1. Can go to property. And then we can change the platform. Example, we use this color. We can go to change the color, right? Color here. For text color, I will use black. And fill color, I will use red because it is stop button, yes. and we can copy one more for start button. Okay, start M1. We can change the label with the start M1. Yes. And then I will change the color to be blue color. Yes. So we can change to blue. Okay. And for the background, we can change to another color that we want. I will change to this color. Yes. Okay. And then we can use the rectangle to show the status of M1. Example, I will choose like this. Okay. But sometimes we can use the lamp. Yes, like this. Can use the lamp to show the status. Yeah. If we okay like this, it will show like this. Yes. So we can change to color. We can change to when off, it will red, and condition on, it will be green. Yes, like this. Okay. So it is the motor M1. So we need to configure the button start and stop, right? So we can go to property, double click, and then choose the bit and choose momentary on. Yes, because we need to turn on, and go to description, destination, and choose the stop, right? Okay. And for start, the same, we can go to bit, momentary on, start. And for this motor, we can go to variables and choose the motor one. Okay. And then we can compile, right? And simulation before download to the HMI. So I will choose text. Okay, welcome to HMI Schneider with S7-200 Smart. Okay. And then we can change the color or change the font size that we want. The text color I will change to be yellow. Yes. So big, right? So we can adjust. Okay, like this. Then this one should be show the status of motor, right? So I will choose the text. For the label, we can use can use the text, right? Okay, here we can write the option. When the motor stop, we can show the stop, and when the motor is run, it will show run. Yes. So we can go to enable the value animation. Position, enable the position, the color, enable the color, it is boolean, right? Mode by state, by form, free form. We can use the value animation. Actually, we can use the rectangle. Okay, I will use the rectangle. Have option or not? We have size, we have type, we have visible. Fill, right? This one have style also. Actually, we can use the text. Let me find the option. Yes. Stop. Normal is stop. And when it turn on, right? When it turn on, it will show running, right? Visible. Okay, so we can translate the text. I will use the label. Yes. And choose the font. It is top, right? I will choose the font size, increase the font size a little bit. So double click on font size and then choose the value. Enable the value animation and choose the boolean. Yes. So here we can choose the motor one. Yes, to translate the text. So when it on, I will show the status with the motor one. running, and when off I will show motor 1 stop. Yes, like this. And for color we can choose boolean also. Color animation, okay. So when off I will show the text is red color, and when on I will show the green color. Yes. And then we can go back to our screen. And then we can save the project and simulation. Yes. Before download to the HMI, we can simulation. Yes. So this one is so big, right? So we can adjust the size like this. And then we can save, and then we can simulation again. Okay, it should be like this. So let's go to download to the HMI. So to download the HMI, I will connect the USB Type B from my HMI to my computer. Okay, I will choose Virtual Machine because right now we use Virtual Machine. So I will adjust the position to be center like this. Yes. So we can push download. It means that download the project to the HMI. Yes, to the real HMI. PLC Connect cannot find the detect target machine, right? So let's check again. Check the driver again. Go to manage to check the driver. Go to device manager, and then we can find the HBT. Yes, you can disconnect and connect again. Okay, it shows like this. It means that the driver is working properly. Then we can go to try to save the project and then simulation again before download. Okay, and then we can push download again. It still cannot connect, right? So let me check the HMI again. And then let's try to download. Okay, now we can download to the HMI. So I will change the USB to be to be 2.0. Yes. and then I will disconnect and then connect the USB again, and then we can try to save and then download the project to the HMI again. Okay, so click yes to confirm download. Yes. We will download the project to the HMI. Yes. So wait a moment for downloading the project. Take time a little bit to download. After that we can test together. So don't touch anything while it downloads. Okay, download finished. So the screen is start up. And then we can go to online with our project. Okay, and then we can test together. Okay, so right now the motor is stopped. So if I push start, okay, the motor is running and the output is turned on. It means that we can connect from this output to the relay or contactor, so we can control the motors. When I push stop, it will stop. Start again, it will start again. Yes. So the condition is stop. This one is running. Yes. So it worked perfectly between HMI and PLC. Yes. And then we can continue to write with another motor. Example, we can go to M0.2, M0.3, Q0.1, and then we can hold the signal by Q0.1. Yes. And here we can define the symbol. Example, stop M2. This one start M2. Yes. And then we can save the project and then download to the PLC. And run the PLC again, and we can online. And we need to add more variables to control the motor number 2, right? So I will adjust. Okay, and then we can copy for motor number 2. So right click, copy, right click and paste. We will got like this for motor number 2. And then we can adjust. Okay, like this, and save the project, and we need to create the new variables of this motor, right? So insert the boolean. So example stuff M2. So M2 address is M0.2, right? So M0.2, and one more, start M2. So the address is M0.3, and one more for M2 command, right? So Q0.1. So boolean Q0.1, and this one motor 2. Yes, and we can go back to our screen, and for this one we can go to property or double click, and then change the general, and then go to the stop M1, right? So we can change to stop M2, and this one we can change to start M2, and for this one we can change M2, and value here we can change M2, and here we can change M2, and here we can change M2, and for the status of M2 here we can change M2, and then we can save and simulation before download to the HMI. Okay, it will like this, show like this on HMI when we download. Yes, so we can save and then download the project to the HMI. Oh, we need to change this one to be M2, right? Okay, go first, and then we can change the button description again, and then download again. Yes, so let's go first. So take time a bit for download the project to the HMI. Okay, finish. So I will rename this one to be stop M2. This one start M2. Yes, save. And then we will try to download again. So wait a moment more for download the project to the HMI again. Yes, to confirm. So wait a moment for download the project to the HMI again. And we can test together after download it. Okay, finish. So we can go to our PLC project and then online and check the status when we push the button motor number 2 and motor number 1. Okay, right now we already downloaded the project from our PC to the PLC, to the HMI. So if I push start 2, Q0.1 is turned on and the status is green, yes. And for start 1, yes, it worked for Q0.0. And we can stop also, yes. So it worked perfectly, yes. So this is just an example about how to connect the PLC S7-200 Smart with the Schneider HMI, yes. So before go to the end of this video, I would like to share this one a little bit, yes. As I show you, if we tick like this, yes, checkbox like this, we can upload from the HMI, yes. So let me save the project first and then I will close all the project and we try to upload, right? So we can go to video designer and I will upload this project from the HMI, yes. Okay, I will create the new project or we can cancel the project. So first we need to save and delete the HMI because when we upload it will duplicate the project, right? So I will delete all the project first. Okay, and then we can try to upload editor project. So click here and then choose the USB because right now we use USB, right? And we choose main drive because we upload from the HMI, yes. So click OK and wait a moment for upload, yes. Upload complete, right? And then we can open the HMI. We will got the original project, okay. So that's why I show if we would like to upload the project, we must check box here before we download the design screen to the HMI, okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon, and I will drop this project example project to the video, and everyone would like to get this project, everyone can download from the link under my video. And the main objective of this project is this connection. If we cannot wiring the connection, we cannot communication or we cannot control the data from the HMI to the PLC, right? So it is very important for the connection of this pin. That's why I explain this pin assigned with the resistance, okay. So if everyone have any more question, please kindly drop comment under my video, yes. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Today I would like to show and share about how to setting the HMI control to PLCs. Okay. Now I have only one HMI model Smart S700 IE V3. Then connected the LAN cable to the Ethernet switch, yes, to the switch hub, and I will connect from the switch to PLC by using the LAN cable, yes. So the concept is, if we would like to control the data from the PLC to the HMI or from the HMI to the PLC, so we can setting the HMI setting, and then we can download to the HMI by using the software WinCC Flexible Smart version 3. And if we would like to create the program inside here, we can use the step 7 microwin smart. Okay, so the benefit of this project is we would like to integrate the data from the two PLCs by using only one HMI. Okay, and then we can control and test with me together. Yes. So here is the IP address of PLC 1, example 192.168.2.1. For PLC 2, 192.168.2.2. And for the HMI Smart 700 IEV3, I will setting with the IP address 192.168.2.3. And for IP my PC, IP address of my PC, I will set 192.168.2.253. So if we would like to test the connection, we can ping from my PC to the HMI to the PLC 2 to the PLC 1. Then we must can connect. Okay. So we will download and upload the program from the PC to the HMI and to the PLC by using the LAN cable. Okay. So let's go to create the project. On PLC S7-200 Smart first for PLC number 1 and PLC number 2. And then we will go to the WinCC Flexible Smart V3 to create the example project and then download to the HMI. Okay, and then we will control the motor number 1 to PLC number 1, the motor number 2 to PLC number 2. Yes. So let's follow me step by step. Yes, together. Let's go. Okay, here is my software. Step 7 microwin smart version 2.5 that I already installed on my PC. And here is the WinCC Flexible Smart version 3. I already installed to my PC also. Yes. So we will use these two software to configure and download the project to the HMI and the PLC. Okay. So first we need to put the manual address of our PC to be the same as my slide. So I will put 192.168.2.253 on my PC. So let's go. IP4, yes. So if everyone not yet put, it become like this, yeah. And if we would like to put the manual, we can use follow IP address here. So 192.168.2.253 and subnet mask is 255.255.255.0. Okay. And we will create the project of CPU 1, right? So let's open the WinCC Flexible, step 7 microwin smart. And first we need to check the communication between our PC to the PLC, right? So right now I will use the CPU SR30 because it is my PLC 1 CPU SR20, yes. And for CPU 2 is CPU SR20 also, yes. So I will put CPU SR20 here, okay. And then for the IP address for communication for CPU number 1, I will put 192.168.2.1, yes. And subnet mask 255.255.255.0 because here is the my IP address of my PLC, yes. And then for the startup, we can run the CPU after power on, yes. And here is the input and output of the CPU, yeah. There are 16 for input and there are 8 for output of this module, yes. And for security we can put the password or anything, yes. So right now I will keep like this first, so only set the IP address of the PLC 1, yes. And then we need to check the communication after we after we created the program, right? So basically I will use the command sample test logic from CPU 1 from HMI to CPU 1, okay. And here I can use NO contact, yeah. Example, I will use M0.0, yes. And M0.0 I will control the output Q0.0, yes. And for next I will use M0.1 control the output Q0.1, yes, because there are 8 outputs, right, for the CPU. So I will use until H, yes. So example M0.2 control the output Q0.2. This one we can also bit 1, yes. This one bit 2, PLC 1 bit 2, PLC 1 bit 3, and this one M0.3 control the output Q0.3. So this one should be PLC 1 bit 4, right? Okay, so this one PLC 1 bit 5. So I will use M0.3, control the output Q0.3, Q0.3, and this one PLC 1 bit 6, right? So we can use M0.5, control the output Q0.5, PLC 1 bit 7. So I will use M0.6, control the output Q0.7, 0.6, sorry. And for this one is PLC 1 bit 8, right? So the last one I will use M0.7, control the output Q0.7. Okay, so the output only 8 bits for this CPU. So let's keep like this first, and then we can save the project. Yeah, example PLC 1. Yes, and then we will create one program that we'll use for PLC 2, right? Okay, so I will open one more for step 7 MicroWin Smart, and then I will go to set the CPU also, right? So this one my CPU is SR20 also. Then the IP address I will set 192.168.0.2. Some name mark the same. And for the input and output, yeah, it is the same as the PLC 1 because the specification is the same. And then for the startup, I will run the CPU also. Yes. And for the program we can edit anything that we want. Yeah. Example, I will use command control data from HMI to PLC 2, right? Because it is PLC 2. So basically we can use the logic the same as the PLC 1. Yeah, example M0.0. We can also create like this. I will use like this SM0.0, and then this one M0.0, control output Q0.0. So this one we can copy like this. This one we can write from bit 1 to bit 8. Yes, and this one we can copy also, and then just change this one to M0.1, and this one output 1, right? Then we can connect, then we can write until M0.7, right? 0.2 Q3. This one should be output 2, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, right? Then we can use control, press control on keyboard and arrow key up, and then we can revise this one to M0.3. This one should be 3, M0.4. Copy and then paste. So this one should be 4, M0.5, and this one should be output 5. So M0.6. This one should be 6, right? M0.5. Sorry, M0.6. This one should be 6. And the last one, M0.7. Output number 7, right? And then we can compile the program. Yes. So there is no error, right? And then we can save our program. So I will save with the PLC 2. Yes. So right now PLC 1 and PLC 2 we already created the logic, the sample logic for test. Yes. Here for PLC 1 and here for PLC 2. Okay. And then we need to download to the PLC, right? So right now I already connected the LAN cable from my PC to the PLC. So we can ping, right? CMD ping 192.168.0.2.1. Okay. So we can ping for PLC 1. And one more, we can also use CMD ping 192.168.2.2 for PLC 2. Yeah, we can also ping because we already set the IP, right? Then we can download. Okay, we can go to the communication here. Then select the adapter of the Ethernet port that we already connected the LAN cable with the PLC. Yeah. So basically we can use the TCP/IP auto. Yes. And then we can search. Okay. So right now it found two PLCs. The first one is 192.168.2.1, and here is the MAC address of the PLC. We can see on the nameplate of the PLC, or we can click plus line this. When we click plus line, it will show on the PLC. Yes, I will show. Okay. Let's see if I click plus line. Let's see the CPU, the LED is bling, right? Yes, for CPU number 1. So we can select the CPU number 1 and then download. Click on download. Yes, because right now let's see here, we already connected the CPU number 1, 192.168.2.1. Yes. So we can select and then download, and then click download. And then we can online and then start CPU. Yes, right now the CPU running. Yes. And for the PLC number 2, we can also go to the communication. Yes. And then search the IP address of the PLC also. Yeah. Click find the CPU. And wait a moment for finding the CPU. Yes. So right now it found 2 also because we use only one Ethernet card. Yes. So click the CPU number 2 and then click OK. And then we can go to download button. Stop the CPU and then run again. So here is 192.168.2.2. It means that connect to the CPU number 2 also. Yes. So all CPU is running right now. All PLC is running. So we need to control this project from the HMI, right? So we need to create the project on HMI. So let's go. I will minimize this first. And then open the WinCC Flexible Smart version 3. Yes. We will create step by step. Yeah. And go to create the empty project here. Click here. And choose the HMI to be the same as our HMI, right? So right now I will use the 7-inch. So my HMI is Smart 700 IEV3. Yes. If we not use V3, we can use this one. If we use V3, we can use this one. Okay. So my HMI is V3. Okay, I will show here. Yes, V3. So I will use Smart 700 IEV3 here. And then here is the version. We can use the version, yeah, another version that we want. Right now I will use version 3.0.2.0 and click here to create the new project. Yes. Okay, so right now the screen, let's see here, Smart 700 IEV3 already created. Yes. So for the background, we can change the background, another background that we want. Example, change to the red color, to the yellow color, to this color. Yes. So we can change it. And it has many features that we can use. Example, symbol. We have many symbols that we can use here. Symbol factory, right? So here many symbol, yeah. Example, chemical, machinery, or pumps, or motors, valve, yeah, tank. So many objects that we can use from here. Yes. The same as my slide, I will create like this also. Yeah, motor. So first we need to test the bits. Yes, that we already created here. Yes, from PLC 1 and PLC 2 from the HMI, right? So right now I will go to the objects, and then I will like this, make like this to separate the HMI. Yes, example this one for PLC 1. Yes, so I will go to property and then increase this one, and I will change the color to be red. Yes, so this one for PLC 1, I will choose text, and then we can write by property, go to the text, example PLC 1, PLC 1 path. Yes, so here I can change the size to be okay like this. If we would like to use the bold italics, we can use. Yes, and we can also change the color. Example, we change to yellow. Yes, and we can adjust the font size 48. Yes, okay, 48. And this one we can copy to be a PLC 2 path. Yes, actually we can simulation, yeah, to see the text that we already created is okay or not before download to the HMI. Yes, so it's good. And then we will continue to create the text on connection, right? So first let's go to add the connection. Go here for this tab for connection. So right now we have two PLCs, right? So I will add for PLC number 1, PLC 1 data, and I will choose the SIMATIC S7-200 Smart. Yes, here. And for the interface, I will use Ethernet. Yeah. And here is the IP address of computer. One 192.168.2.253. Yes, and for the PLC 1 is 192.168.2.1. Yes, so I will put 192.168.2.1. Yes, and one more for PLC 2 data, right? So here PLC 2 data, and the IP address of computer is the same, but this one should be changed to 2, right? Because here 192.168.2.2. Yes, so in this step is very important. If we don't know how to setting the IP address of this module, it will not work, right? So here, so PLC 1, let's see here is 192.168.2.1, and for the PLC 2, 192.168.2.2. Okay, and for the IP address of my PC, I will fix the same as the PLC 1 and PLC 2, right? And then we can save the project. Okay, then we can save. So right now for the connection, we already connect for HMI 1, connect to PLC 1, HMI 1, connect to PLC 2. So we need to create the text, right? So let's click here to create the text. For text, we already define here for PLC 1, right? Let's see. We will start from M0.0 until M0.7, and for Q it is the status. When we push the button or switch, the output is turned on also, right? So we need to show the status of output on the HMI also. So we will start from Q0.0 until Q0.7. Okay, so we will create the text, follow this step. I will put like this. Okay, so first I will start from PLC 1 M0.0, right? So here is the connection that we need to know and choose the correct connection. Otherwise, when we choose the wrong connection, when we control to the PLC 1 example, but here we choose the PLC 2, then the data will wrong control, right? So let's check here is make sure we choose the correct connection of PLC that we would like to control, right? Okay, so right now I will put PLC 1 data, yes, and the data is Boolean, and start from M0.0, right? So M0.0, I will choose M0.0, okay, and for the M0.1 until 7, we can drag and drop like this. Okay, so M0.0 until M0.7, right? So this one I will delete, this one I will delete, yes. So we can keep like this. And then for the output, we also create the status for show on the screen, right? So it will start from Q0.0. So here PLC 1 Q0.0, then the connection is PLC 1 also, PLC 1 data, and here it will start from Q0.0, right? And then we can make like this also, yes. So it will start from Q0.0 until Q0.7, right? Okay. So for the take of the PLC 1 we already create on the HMI. So here we can go to the screen. Yeah, go to our screen. And then we need to create the button or switch and create the lamp for show the status here, right? So basically we can go to the button here. I will use the small button, or we can use like this. Okay, I will design first and then copy to a switch or a button. So let test here, example bit 1. Okay, bit 1 we can copy for bit 2, copy for bit 3 and bit 4, and we can copy bit 8, right? Okay, we have 8 bits for test here. So this one I will change to be bit 1 until bit 8. Okay, bit 1, this one should be bit 2, right? This one should be bit 3. This one should be bit 4. This one should be bit 5. Bit 6. Bit 7. Bit 8, right? We have 8 bits. And then we also have 8 status, right, for output. Yes, here. So I will use like this. Yes. Then copy. Maybe we can increase to bigger than this one. Yes, just copy by press Ctrl and drag. Okay, then we can arrange. Basically, we can click Shift and then click here and click like this. Then we can arrange. Yes, we can arrange to be like this. Okay, so we can copy also for PLC number 2, yeah, because we create the same as this one. So here we can drag like this. Okay, we will go like this for PLC number 2. So right now we need to configure the switch and the status of bit on the PLC number 1, right? So I will go to event, click and then invert bit. So bit PLC1 M0.0, right? PLC1 M0.0 here. And for bit 2, we can also invert bit. PLC1 M0.1, right? We can do the same as the procedure. So invert bit PLC1 M0.2, this one, invert bit PLC1 M0.3, invert bit PLC1 M0.4, invert bit PLC1 M0.5, invert bit PLC1 M0.6, the last one, invert bit PLC1 M0.7. Okay, so that's all for button configuration. Yes, and then we can configure the status of the lamp also, right? So let's go to the animation and then choose the text, this one, and we can type also M PLC1 underscore Q 0.0, right here. So bit, and when it 1, it means that it's true. I will change the color to be green. This one also PLC1 Q0.1, yes, bit also, and when it 1, I will change the color to be green. PLC1 Q0.2, bit 1, change the color to be green. PLC1 Q0.3, when it's true, I will change the color to be green. PLC1 Q0.4, when it's 1, it's true or it's on, I will change color to be green. PLC1 Q0.5, yes, when it's 1, I will change the color to be green. This one PLC1 Q0.6, when it's 1, I will change the color to be green. The last one for PLC1 Q0.7, bit, when it's 1, I will change to green. Okay, and then we can save the project. Basically, we can simulation before download this project to the HMI, right? So we can simulation to see the status of our button and our lamp. Yes. So here we can also click. Yes, when I click, the PLC is turned on. Yes. Let me show when I click. Okay, when I click the button, let's see the PLC is turned on. Output. I will click more. Yes, turn on, turn on, turn on, turn on, turn on, and turn on. So 8-bit is already turned on. Yes. And also we can turn off. Yeah. We can turn off from the simulation. Yes. So we need to do the same as the instruction here for PLC2. Yes. So I will close first. I will turn off for all bit. And then we need to create the text for PLC2, right? So go to the text. Okay. So this one we should start from PLC2, right? PLC2 underscore M0.1, sorry, 0.0. And here is very important, so we must use the PLC2, otherwise we control the wrong location. Yes. So I will choose the PLC2 data. It is the Boolean and start from M0.0 also, right? So here we can draft. Okay, we will got like this from M0.0 until M0.7 of PLC2 here. Yes, PLC2. So we have M0.0 until M0.7 and Q0.0 until Q0.7. Yes. So for M we already create it, and then we can go to PLC2 underscore Q0.0, right? The connection is use PLC2, the Boolean, and the address will change to Q0.0. Yes. And then we can drop, yes, 4, right? 5, 6, 5, 6, 7, yes, enough. So Q0.0 until Q0.7. Okay. And then let's go to save the project again. And here actually we can delete first because we already config here. Then we can delete, just change the name, right? I will select and then copy. Press on the keyboard Shift keyboard and then click. And we would like to copy, just press the Control on keyboard and then drag the mouse. Yes, we will got like this. So here for the bits and for the lamp, bit, button and lamp is the same, right? For PLC1. So we just go to change here. change to PLC2. Yeah, we will go like this. Change to PLC2. 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 And for the status also, yeah, go here, animation, this one, PLC2. PLC2. The last one is PLC2 also, right? Okay, so that's all. And then we can save the project and we can simulation. So for the PLC2, we can click here, bit 1. Let's see, this one PLC1, right? So I will open the PLC2 here. Bit number 1 is turned on, and then the PLC is turned on also. Let me show the status on PLC. Yes, the bit number 1 of output is turned on right now, PLC2. So if I push more button or more switch here, turn on. Number 3 is turned on. Number 4 is turned on. Number 5 is turned on. Number 6 is turned on. Number 7. Turn on, and number 8 is turned on. Okay, and we can also turn off the bit, each bit that we want. Yes, so it works. Then we will download this project to the HMI, right? So I will close the runtime first, and then we will download this project to the HMI. But before download to the HMI, let's go to setting on HMI first. Let me show. So to download to the HMI, first let's go to control panel, and then go to the transfer. So we need to enable this function, otherwise we cannot transfer from our PC to the HMI. Yes. So if like this, we cannot transfer, right? So we must put like this, then click OK, and let's go to see the set the temporary IP address here. So right now the IP address of this one is 192.168.2.3. Yes. So if we would like to modify some IP address like .3.3 like this, we can modify, but right now I will use .2.3 to be the same as my PLC 1 and 2 here. Yes, and then click OK to confirm. Yes, and then click transfer. Yes, and let's go to our PC. So I will download the project from my PC to the HMI, right? Okay, and then can go to this button, and here is the setting. Yes, so we need to put the IP address of the HMI, right? So 192.168.2.3. Yes, this IP address, and no need to tick this one and this one. So just click here for transfer. Okay, finish. So I will show the status on the HMI. So here we can also online. Okay, runtime like this. Simulation also. So here we can put like this for CPU 1 and CPU 2 of PLC, and here is the screen HMI. Yes, so we can put here the HMI, the real HMI is also working. Yes, okay, we'll put like this, and then we will control from the actual HMI, right? So let's see, here is the HMI. Okay, let's see, here is the project of HMI that we already download. Yeah, so we can press here to control. Yeah, let's see, the PLC 1 is turned on. Turn on. Yeah, turn on. Turn on, turn on, and turn on, right? So if we would like to control the PLC number 2 here, yes, I will push. It will turn on. Push number 2, turn on. Number 3, turn on. Number 4, number 5, number 6, number 7, and number 8 is turned on. So right now the PLC 2 and PLC 1 is turned on, and the HMI is show the status also. Yes. And then we can create the more feature that we want. Yes. Example, I will create one more program for control one motor. Yes. So here I will start from example, I will start from M0 sorry 1.0 M0 sorry M example M5.0, yeah, for motor 1. Insert the column, and here I will use stop. So M1.1, and I will hold the signal here M5.0, yes, and then we can download to the PLC 1 and then start again. We can online, yes, and we need to create the text on the HMI, right, for control the motor. To create the text, let's go to the text. So I will start from M1.0, right, for start. So this one should be PLC 1 M1 start, and here we need to select for PLC 1, right? So it will start from M1.0, and this one for stop, right? M1.1, and for status of the motor 1 is 5.0, right? So PLC 1 M1 status M5.0, yes, and for the PLC number 2 I will create the same as this one, yes, so we can copy and then paste, and we can change this one to be PLC 2, and this one should be changed to 2, PLC 2 also. This one should be changed to PLC 2 connection, and this one should be PLC 2 also. I will change the connection to PLC 2 data, yes, and then we can create the new for start and stop the motor, right? Example, this one for start, and this one should be red color, right? And I will change the size of the text to be 24, and then we can copy here, for stop, right? Okay, start should be green and stop should be red, right? So I will rename this one to be stop. Okay, and then for motor we can go to the symbol to create the symbol here, yes, actually we can go this step, yeah, we can go to this step and then go to the symbol factory graphics and then go to symbol factory here and then go to choose the motors or pump or another symbol that we want. So right now I will use the motor. Yes, drag and drop the motor to put here. Yes. And I will put the status of the motor, right? So I will drag and drop one more motor to the PLC 2. Okay, I will use this style. Okay, and then go to the symbol and I will use like this for status. When motor run, should be change the color to green, right? So basically I will use red color for not run. So this one should be a config also for this button. So start, let's go to event and then go to preset. Yes, preset, it means that set bit and then set bit PLC 1 start, right? PLC 1 M1 start. Yeah, PLC 1 M1 start here. And for the release, we will reset bit, right? PLC 1 M1 start. Yes, because when we push the button, it will be hold. Okay, so we can press and release. Yes, so set and reset bit, and this one also when we press set bit PLC 1 underscore M1 stop and release reset bit PLC 1 M1 stop, and we can also show the status of the motor when run, right? So go to PLC 1 M1 status bit. I will change to 1 and change to green color. Yes. So we need to create the program on the PLC S7-200 Smart software to create this motor also, right? So let's go. So I will offline for PLC 2 and then I will create the network number 2, control the motor from HMI. Yes, and then I will use start M1.0 stop, sorry, M1.1 for the status M5.0, and I will hold the signal when M5.0 is turned on. Then I will download Okay, and then go to the HMI again, and we can copy from this one and this one. So click Control on the keyboard and then drag the mouse. We will go like this. Okay. For the button start, I just change this one to be PLC 2, right? And this one also PLC 2, because we already created the text, right? This one also PLC 2. Yes, and this one PLC 2 also. Go to animation, just change the text to PLC 2. That's all. And then we need to download the project to the HMI also, right? So I will simulation first to check the status. Okay, we can please start. We can please start. Yes. Can please stop. Start. Stop. For PLC 1, we can also please stop. Start. Stop. Start. Okay. It worked properly, so we can download the project of HMI to the HMI. Yes, let's download again. Yes, it will update the screen. Okay, finish. And then this one we can online simulation. For PLC 2, I will drop to here, and PLC 1 I will put here. Okay, then I will online like this. Actually, we no need to online like this. It will work also. Yes. So let's control the logic from the HMI. So for motor number 1, I will stop. When I stop here, the simulation will stop also. I will start. It start. And for motor number 2, I will press start. It will start. I will press stop. It will stop. Yes. So it works properly between both PLC and only one HMI, right? So this is just example about how to create the program for test two PLCs with one HMI that I already showed step by step about how to create the project of step 7 MicroWin Smart for PLC 1 and PLC 2, and also create the WinCC Smart program for control the PLC by using the HMI. Yes. So this is just concept. So if everyone have the project, we can design. Yeah, we can use another style that everyone would like to design. Yes. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment. under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say I'm sorry if I have mistake in this video, and bye bye, see you next videos. Today I would like to show and share about how to control the data from only one HMI model Smart 700 IE V3 to 3 PLCs. Before go to create the new project of Step 7 MicroWin Smart and WinCC Flexible Smart, I would like to explain the concept a little bit. There are 3 PLCs model SIMATIC S7-200 Smart, CPU SR20 for PLC 1, and for PLC 2 I will use SIMATIC S7-200 Smart but CPU SR30, and for PLC 3 I will use SIMATIC S7-200 Smart, CPU SR20 also. Okay, and I will connect the Profinet port from those PLC to the switch, and then set the manual IP address of PLC 1, PLC 2, and PLC 3, the same as I show. Example, PLC 1 I will set 192.168.20.1, PLC 2.20.2, PLC 3.20.3, and for HMI I will set .20.4, and for my computer I will set .20.253. Okay, and the concept is we can separate the page of the HMI that I will show step by step about how to create the connection. If we would like to control from the HMI to PLC 1, we can use the connection for PLC 1. If we would like to control the data to PLC 2, we can also set for connection for PLC 2, and we can separate the page one by one to control. Yes, I will show step by step during we create the project of step 7 MicroWin Smart and SIMATIC WinCC Flexible Smart version 3. Okay, so this is just wiring. So if we connect like this, it means that we can communication between our PC to the PLC 1, PLC 2, PLC 3, and also HMI, because the IP address is the same as class, right? So this is just concept. So let's go to create the project step by step and easy to understand. Okay, so let's go to follow me step by step. So here is the software SIMATIC WinCC Flexible Smart and Step 7 MicroWin Smart that we will use to create the project. Okay, so before go to create the project, I will create a new folder. Example 1 HMI connect to 3 PLC, right? Okay, and then we will create the project and then download to the PLC 1, right? And I will explain how to set the IP address and set the CPU status. When we power on and power off, the CPU is running or stop or last. Okay, so let's go to open step 7 microvin smart. Okay, so here is the default program. When we open the software, we will got the window like this. And first, we need to insert the CPU, right? So the CPU one, I will use CPU SR20. Yes. So let's go to insert the CPU SR20. Yes. And for the startup option, I will use run mode. If we select run, it means that when we power on, it will run the CPU. And if we choose stop, it means that when we off the power of PLC and power on again, the CPU will stop. When we select last, it means that when we run the CPU and we turn off the power of CPU, when turn on again, it will run because it remember about the last. Okay, so basically we can choose run because actually when we power on, it will allow PLC to run, right? So let's choose run and then click OK. And we can communication between our computer, yes, to PLC, right, to check communication. And before go to communication, let's go to set the manual of our computer, right, IP address of our computer. Okay, here is the manual IP address of computer. Actually like this, if everyone not yet set the manual IP address, so we can right click and then open network and sharing center and then go to local area connection and then choose the property and then go to IP4. Yes, TCP IP4 and then choose 192.168.20.253, right? The same as my slide here. Yes. And pre-step, it will fill the subnet mask for us. Yeah. 255.255.255.0. Yes. And then click OK and OK again. And close. And then go to communication for CPU number 1, right? So go to double click on communications and then choose the Ethernet adapter. Yes, and wait a moment for scan the CPU. Take time a little bit. So right now we found 3 CPU. The first one is 192.168.2.2. Second one 192.168.2.3 and the third one is 192.168.20.1, right? So basically we can click on the IP address which one that we want to configure for PLC1. Yes, example, I would like to set this one for PLC1. I just click the plus line and then take a look to the PLC. It will blink the network. Yes. So let me press the plus line and then let's see the status together. Okay, let's see. It blink, right? Okay, blink. Plus line, right? So this one is blink. Let's see. Yeah, this one. Blink, right? So this is a PLC one. Then we can stop plus line and then go to edit, right? So 192.168.20.1, yes. Then set and then click OK. So we will got IP of PLC1, yes. And then we can create the new project of PLC1. Example, I will create the push button stuff. Example, stuff M1 M0.0 stop M1 M0.1 start M1 and then I will control turn on the Q 0.1 sorry 0.0 and I will hold the signal by Q 0.0, yes, and then we can compile. Okay, no error occur, and then we can save the CPU 1, yes. Let's check, go to one HMI connect to 3 PLCs, right? So example, this one PLC 1 or CPU 1, yes, and then we can download to CPU 1. If I download, the CPU 1 will stop, right? Let me show when we download. So right now the CPU is running. So when I press stop, let's see the CPU 1 is stopped. And then download finish and press yes to run. Yeah, CPU 1 is run. And then we can online. We can go online. Yes. Okay. And for CPU 2 and CPU 3 we can follow the step. Yes, I will minimize this one first and then open for create the CPU 2. Okay, so first let's go to set up the CPU type, right? The CPU type is SR30, right? So let's go to choose the CPU SR30, yes, SR30, and then go to start up and then choose the run mode also, yes, and then press OK. And let's go to tick the communication and then choose the correct network adapter, and it will pop up the IP address of the PLC, yes. Okay, so to make sure which one the PLC2 that we would like to set, we can press another IP address, and then we can press plus line, right? So let me press plus line. Okay, let's press the plus line. Let's see the CPU middle is bling, right? It means that the CPU2 that we would like to set the IP address 192.168.20.2, right? Okay, so we can go to edit. So this 1.20.2, right? Preset. Okay, finish. And then we can create the logic. Yes, example M0.0, M0.1, yes, M0.1, Q0.0, and I will hold the signal by Q0.0, right? Okay, and then we can compile. Okay, no error occur, right? And can save the CPU2. Yes. Okay. The CPU2, and then we can download. When we download, the CPU2 will stop also, right? So let me show the condition when we download. So when we download, click yes, it will stop the CPU2. Yes. And then finish, click jack again to start the CPU2. Yes. And then we can close, and then we can online. Yes. So we can minimize for CPU2. Yes. And go to step 7 microwin smart again for CPU3. So first let's go to set the CPU type, right? The CPU type is SR20 also. Yes. So let's go to setup, and then choose the CPU SR20 and go to start up, and I will run the CPU when power on. Yes. And then go to communication tab and choose the correct network adapter, and it will detect the 3 CPU also, right? And then we can press plus line, yes, to check to make sure the CPU is correct, right? So this one I will press plus line. Okay, let's press plus line, and let's see the condition together. Okay, let's see, bling when I press plus line. Yes. So we can set the IP address follow the slide 192.168.20.3, right? So let's go to set, and then .20.3, right? Okay, .20.3 preset, and then click OK, and we will create the sample project, right, for CPU3. Q0.0 also, right? Q0.0, and then I will hold the signal by Q0.0. Okay, and then compile the program. Okay, no error occur, and then I can save with the CPU3, right? Okay, and then we can download. Yeah, please button download. And then the CPU will stop also, right? When we download, I will stop the CPU. Let's see the status. When pre-stop, the CPU will stop, right? And then download. After finish, click yes again to start up the CPU. Yes. So right now all CPU is running. And then we can go online. Go online, yes. So I will put like this. This one for CPU 1. This one for CPU 2 and this one for CPU 3, right? Okay, I will put like this. So this one we can put like this. Okay, and this one we can put like this. So we need to control all this data from the HMI, right? Actually, we can force the signal to see the status. Example, CPU 1 we can write, and let's see the output is turned on, and actual PLC is turned on also, right? Okay, I will write to off and then turn off. Yes. And then write to off again. Yes. So we can create the project from the HMI to control this 3 PLC. So let's go to WinCC Flexible Smart. Yes. Actually, we can simulation and download the project to the real HMI. Yes, I will show. The first one, I will show how to simulation, and the second one, we will download the project from this WinCC Flexible version 3 to the HMI. Okay. So let's create the new project, and I will choose Smart 700 IEV3, the same as my HMI hardware. Yes, so I will choose this one. Yes. So this is very important. If everyone have any HMI, we can choose the correct HMI. Otherwise, we cannot download from the project of WinCC Smart to the HMI. Okay, so let's choose the correct HMI, the same as our hardware. So click OK. And the first step, we need to create the 3 connection, right? Of PLC 1, PLC 2, and PLC 3, right? So let's go to create the connection. Double click here. Example CPU 1. Yes. And I will connect to SIMATIC S7-200 Smart, right? So choose 200 Smart. And I will choose the Ethernet port. Yeah. And here is my IP address of computer. So 192.168.20.253, right? This one. Yes, this one. And I will connect to PLC 1. So PLC 1 IP address is 192.168.20.1, right? And the next step, we will create the IP address or device for PLC 2. So I will choose CPU 2 and connect to SIMATIC S7-200 Smart also. And the IP address of my PC is the same, but this one I will change to 2. Yes, the same as our slide. Yes, PLC 2 is .2, right? .20.2. And for PLC 3 CPU 3, I will connect to SIMATIC S7-200 Smart also, and this one I will change to 3. Yes, so connection for CPU 1 is .1, CPU 2 is .2, and CPU 3 is .3. Okay, and for my PC is .253. Yes, so right now we already create the connection of 3 PLC. Yes, the same as this one. So we can command like HMI connect to PLC 1, and this one HMI connect to PLC 2, sorry, and this one we can mark as HMI connect to PLC 3. Yes, like this, for easy to understand. So the next step, we will create the text. So let's go to this tab for create the text. So one CPU we have 3 texts, right? The first one is stop, the second one is start, and the third one is output, right? So we will create one by one. So example, this one we can choose the text. Example, stop PLC 1 stop M1. Yes, and choose the correct CPU. This step is already create the CPU, right? So we must select to be correct the CPU. Otherwise, when we control, it will wrong direction. Example, we would like to control to the CPU 1, but we choose the CPU 2 connection, it will wrong. Okay, so let's choose the CPU 1. And for data type, I will use Boolean and start from M0.0, right, for stuff here. Sorry, stop. This one CPU 3, but the same, right? Okay, for CPU 1, M0.0 is stop, M0.1 is start, and Q0.0 is output, right? So I will choose M0.0. This one we can go to create for start M1, right? Okay, and M0.1 start M1. And for the output, we can use PLC1 underscore M1. Yes, and then I will choose the Q0.0, right? It is the output. So we can create more for CPU 2, right? So example, PLC2 stop M1, and this one I will choose the CPU 2, right? Here, because we will control the stop button to the CPU 2. Yes, and the address will start from M0.0 also, right? Okay, CPU 2 here, M0.0, M0.1, Q0.0. Okay, and this one we can start M1, right? The CPU 2, right? The same as the take number 1, and then M0.0, sorry, M0.1. And for PLC2 M1, right? CPU 2 connection is CPU 2 Boolean, and I will start from Q0.0. Okay, and for PLC 3 we can also PLC 3 stop M1 and choose the CPU 3, and the address will start from M0.0. Yes, this one. CPU 3, M0.0, M0.1, and Q0.0. Okay. So PLC 3 start M1 Boolean also, and start from Q 0.0, right? Okay. So take for M1 CPU 1, M2 CPU 2. Oh, this one, sorry, it will start from M0.1, right? And one more, PLC 3 M1, right? Boolean also, and CPU 3 connection, and it will start from Q0.0. Okay. So right now for take PLC 1 we already created, PLC 2 we also created, and PLC 3 we also created, right? So let's go to our screen. I would like to separate 3 screens. The screen number 1 for PLC 1, and I will create one more screen for PLC 2, and we can rename this one example main page. Yes, I will rename as main page. Property example main screen. Yes, and this one I will use for PLC 1 screen, and I will create more for PLC 2 screen, and one more for PLC 3 screen. Yes, so I have main screen here, I have PLC 1 screen, PLC 2 screen, and PLC 3 screen, right? So I will call the main button. So main button we can go to create a button for call the screen 1, screen 2, and screen 3. So I will put this one first and then choose the text. I will write the text. Okay, welcome to PLC and HMI training. I can choose the font size to be 20, yes, like this, and I will change the background to be okay, maybe yellow color is okay. Okay, yellow color, and I will change this one to be example 28. Is okay or not? 28. Okay, it's still okay. So we can simulation to check the screen is okay or not. Okay, that's okay, but I will change to be center and middle, right? I will go center and middle. Okay, like this. Maybe I change the background to another color. Example, this color. Okay, this color. And then I will change this one to be 30, sorry. And then let's simulation again to check the screen. Okay, Tony is okay, right? And then we can put the button for call the screen, right? Example, I will call the screen. Go to property. Go to property, and this one example PLC one screen. Okay, call the PLC one screen, and then I will adjust the font to be 16. Yes, and this one I will put PLC 2 screen. Yes, PLC 2 screen, and this one PLC 3 screen. Okay, so we have 3 buttons for call the screen, right? So when we push this one, we will got the screen number 1 PLC, and when we push this one, we will got the PLC 2 screen. Push this one, we will got the PLC 3 screen, right? Okay. So to call the screen, we can go to property and then go to event, click, and then choose the activate screen. Yeah, this function, activate screen, and then we can choose the screen name, right? We can click here. So we can go to screen 1, PLC 1 screen. Yes, and for this one we can activate screen also, and choose the screen name, screen 2, right? And for this one, activate screen, so screen number 3 here. And then for screen number 1, number 2, and number 3, we can copy this one. Yes, so copy and then go to PLC 1 screen, and we can paste. Yeah, we will got like this. Go to, okay, I will change the background a little bit to be this color for screen number 2. Sorry, for screen number 1, and then we can copy this one to screen number 2, and then paste. Number 3, paste. Yeah. So we can go to screen number 1 and number 2. I will change the background to be this color. Yes, maybe this color is okay. And for screen number 3, I will change the background to be this color. Yes, and then we can save the project. Go to desktop and then go to choose the one HMI connect to PLC 3 PLC, right? So this one HMI project. Okay, so we can simulation for open and close the screen for test. So this one is main screen, right? So I will call the screen 1, yes, call the screen 2, call the screen 3, call the screen 1, call the screen 2, call the screen 3, and we can also call main, right? So I will add more for main screen. So let's adjust button a little bit, and then I will copy one more for main screen. So this one we can write go to main screen, right? Or we can write only main screen. Okay, and then we can adjust a little bit more. Okay, so this one we can call the main screen, right? So I will go to event and then choose this one as main screen, and then we can copy to paste on screen number 2, and then we can adjust this screen. Okay, and then go to screen number 3, and then we can paste and adjust the screen also. Yes, and then we can save and simulation the screen again. So right now I will switch to screen number 3 and then go to main screen, screen number 2, main screen, screen number 1, main screen, and also go to screen, another screen we can select, right? And here maybe I can put the text. Okay, we can copy. So this one example main screen. Okay, main screen, I will go to the font size, adjust to 24, sorry, maybe 48, yes, main screen 48, and then we can copy and then go to PLC 1 screen. So this one should be I will change color to be this color, and then change the text as PLC 1 screen. Yes, and then we can go to copy and then paste here. So this one should be PLC 2 screen, and then copy and then paste here, should be PLC 3 screen. Yes, and then we can save, and we will create the button for start and stop and status the motor of each screen, right? So let's go to screen number 1 first, and then choose the button. Yes, example, choose the button for start. We can write as start motor 1. Yes, I will change the color to green color, sorry, change the color to be green or blue color, yes, blue color, and I will adjust the size to be 16. Yes, so this one start motor 1, and we can copy for stop motor 1, and adjust the text. So this one should be stop motor 1, and I will change the color to be red. Yes, red color. And then we can go to choose the motor, right? So let's go to choose the motor here. Yes. Go to WinCC Flexible and go to this tab and choose the symbol factory graphics and go to another tab that we want. Example, I go to this tab and then find the tab of motor, right? Okay, motor here. And then we can choose another style that we want. Example, for motor number 1, I will choose this style. Yes, drag and drop. Okay, we will go like this. Okay, and we can adjust the size that we want. Yeah, for this style, everyone can design another style that we can look with the beautiful screen. Yes, so we can adjust to be aligned. Yes. Okay, and then save the project, and we need to configure the button, right? So this one start. Okay, for button start, let's go to event and then go to press. So when we press, it will set the bit, right? So I will choose set bit and choose the bit PLC1 start, right? Okay, start. And then when I release the mouse or release the key on the HMI, I will reset the bit, right? I will reset the PLC1 take start also, right? And for the button stuff, we can follow this step also. Set bit. So set bit PLC1 stuff. And when I release, I will reset the PLC1 stop, right? PLC1 stop. Okay. And for the status of the motors, we can choose another color that we want. I will go to the object and then choose like this. Normally, I will change this one to red, and when the motor is running, I will change to green, right? So I will choose take PLC1 M1, right? And then when it means that it turn on or it running, I will change color to be green. Okay, save the project, and we can simulation for test for PLC1. Yes. Okay, so PLC1, this one, right? So let's go to screen 1. Yes, we will go like this, and then we can start. Okay, when start, let's see the output is turned on. Yes, and then the motor will change to green also, right? And when I press stop, it will stop. Start again, it will start again. Stop, it will stop. Okay, so we can copy to another screen. Yeah, screen 2 and screen 3. So I will select all and then right click, copy, and then right click and paste here. We just change the text for event, right? Go to event, please. Just change this one to PLC2. Yes. and then this one also change to PLC 2, and for stop we can change to PLC 2 also, and release change to PLC 2, and for the status we can change to PLC 2 also, right? PLC 2 M1 status we can simulation, yeah, to check. Okay, I will minimize, and then this one for PLC 1, sorry, PLC 2, right? So let's go to PLC 2 and start. Okay, turn on, stop, start again. Yes, so that's correct. And then we can copy to PLC 3 screen also, right? So I will select, then right click, copy, and then go to screen 3, right click, paste. Yes, and then we just change this one to be PLC 3, right? This one also change to PLC 3. Yes, so it's very easy to control. Yes, this one change to PLC 3, and this one change to PLC 3. Yes, so the last one change the PLC 3. Yes, and then save the project so we can control to all screen. Yes, so first let's go to screen number 3, yeah, to confirm this one working or not. So let's click start. Yes, when I start, let's see it turn on, the motor is running because output is turned on. Stop, start again, stop, start again. Yes, so it worked perfectly. Yes, this one start. Yes, it worked perfectly between 3 screen. And for the main screen we need to show the status of the motor also, right? So example, we can copy, or we can show only the status of the motor run or stop, right? So basically we can use copy, yeah, copy this one for motor 1, right? Copy to screen 1, yeah, this one for motor 1. I will adjust to small a bit. Yes, so we can copy to motor 2 and copy to motor 3. Yes, like this. Okay, and we can put the name, example motor 1. Okay, and this one for motor 2, copy, and this one for motor 3. Yes, and I just change this one to be PLC 2, right? And this one to PLC 3. Okay, and I will change the background to be like this, maybe easy to understand. Maybe like this. Oh, cannot see, right? I will change color to be another color. Maybe change to yellow. Yes, For main screen, I will change to green. Okay. I will choose ball. And we can adjust. Yes. Okay. And I will adjust the size to be 36. Yes. Because it's just the motor name. Yeah. Motor 1, motor 2, and motor 3, right? And then save the project. And we can simulation again. Okay. Oh, this one is not okay, right? So we can adjust to be like this. Yes. And this one like this. And then simulation again. So we must simulation before we download to the HMI. Otherwise, like this. Let's see. Here is hidden, right? Because it look like a big size, right? So I will go to 29 and then adjust and then simulation again. Try to simulation before download to the real HMI, right? So let's see. Right now the motor 1, motor 2, and motor 3 is running. Yes. So if we would like to stop, we can switch to screen mode and then stop and go to main screen. Let's see. The motor 1 is stop. Stop. Okay, I will stop. And let's see. The motor 2 is stop also. And I will stop this one also for motor 3. Yes, it shows stop. Okay. So if we would like to set the analog, yeah, example we can set the analog also. Let's go to test. For digital we already tested, right? For PLC 1 example start, PLC 2 example start, PLC 3 example start, and main screen also show the status of the motors 3, 2, and 1 is running. So right now we will go to create more for analog set point, right? Yes. Okay. So first let's go to PLC 1 because we need to set the value to the PLC also, right? Yeah, if we have the project. Example set point the speed of the motor, set point the frequency of the VFD. Yes. So we need to put the analog value. Okay. So basically we can use like this. Example we can use SM0.0 all the way on. And then I will use add real. Example add real. So I will add VW, sorry, VD 10 and VD 20. Yes, and then the result is VD 30. Yes, like this. And then we can compile the program. Okay, no error. And then save. And then we can download to the PLC 1. Stop the CPU again. Click yes to run the CPU back. And then we can online. Yes. So 0 plus 0 equals 0, right? Example 0, I will 10 plus 0 equals 10, right? Example 10 plus 12 equal 22, right? So we need to set the VD10 and VD20 from the HMI of PLC1, right? Okay, so we can test. So first we need to create the text, right, for PLC1. Example, real one, PLC1 real one. Yes. And I will choose the real and VD, right? VD 10, PLC 1, real 2, right? VD 20, right? So VD 20, because our program is VD 20 also, right? This one. And the result is VD 30. So PLC 1 real Q VD 30. Yes. And then let's go to screen 1. And then we can choose the I/O, right? This one. So example, I will use this format. Like this. Yes. And then let's go to the text. And this one for input and output. This one for input. So the input number 1, I will use input for set the data. Yes. And let's choose the text. Sorry, PLC1 real one, right? And the format, maybe I choose this format. Yes. And then we can design. I will choose the green for text, and background I will choose red. And this one I will choose this one. Font size I will increase to be 22. Yes. And for the text format, let's go to text format. I will choose center and then middle. Yes. So this one for in one, right? Input 1. So we can copy from this one and then choose in 1. Yes, input 1 and then adjust the size to be like this, and change the color. I will change yellow color. And for input number 2, we can copy. Yes. For input number 2. And then I will change this one for input number 2. And the format is the same, right? We just change to real 2. Yes. And one more is the result, right? So result in 1 minus in 2. Sorry, in 1 plus in 2, right? So in 1, example in 1 plus in 2. Yes. In 1 plus in 2. Equal output, right? Maybe I will adjust this motor to like this. Okay, then this is the result, right? So we can copy and then change the format to be output only, right? So this one output only, yes. So if we save the project and then simulation, we will got the result, right? Because we already forced the signal, yes. Screen 1. So this one example I set 40. Oh, I will remove all 4 first. I will unforce first. Unforce all, right? And then we can set example this 120 equal 20, right? Incorrect. So I will change this one to be real 3, yes. PLC 1 real 3, right? And then we can simulation again. Okay, right now 0. Maybe we can use the function like this. Can read also, so we can choose this one, yes. Okay, then we can simulation again. So I will test with 40H. Oh, not come, right? We did 10. Let me check the CPU. Maybe incorrect the text, right? Oh, this one CPU 3 incorrect. So we can choose CPU 1 first. So it is very important. If we select the wrong CPU, it means that the wrong connection also, right? So be careful for this step. And then we can simulation again. Okay. And then go to PLC 1 and this one maybe it's okay. I will change to 40. Yes, 40 equal 52, right? And this one I will change to 20. Yeah, the result is 60, right? Example I will change to 90. Yeah, 110, right? Okay, so it worked perfectly. And then for PLC 2, PLC 3, we can create the program the same as PLC 1. Okay, let's go to PLC 2 first, offline, and then we can use SM0.0, it means that always on, and I will add real VD10, VD20, VD30, yes, and then compile the program, yes, no error, and then we download to the PLC, and then run the PLC back, and we will go like this, and we can go to PLC 3, yes, also go offline and then go to add the always on, yeah, SM0.0. I will choose add real, so VD10, VD20, VD30, yes, and then compile the program, no error, save the project, and then download to the PLC and stop the CPU, yes, and then we can online also. So PLC 3, PLC 1, and PLC 2, we already created the sample for add the value, right? So it worked perfectly. Okay, I will zoom a little bit like this. Okay, and one more for this one. Yes. So PLC 1, PLC 2, PLC 3 is already created the add block. And then let's go to create the HMI. Yes. So first let's go to text, and then this one actually we can copy and paste and just change this one to real one of PLC 2 and choose this one. Yes, don't forget choose this one, this connection. And for this one is real 2, PLC 2, and choose CPU 2, and this one PLC 2 also, and choose the CPU 2, and we can copy and paste here. This one should be real one of CPU 3, and don't forget change this one to 3, real 2 of PLC 3, change this one to CPU 3, and output for PLC 3, choose the PLC 3, yes, CPU 3, and then go to the screen. So the first one is already created, right? So we can copy. I will align a little bit and then copy. Yes. Control C. Paste. Yeah. And I will adjust this button and motors a little bit like this. Okay. For this one, we just change to PLC 2. Yes. Change to PLC 2 because the text is the same. This one change to PLC 2, and we can save and then simulation again. Okay, so this one is a PLC 2 program, so we can test screen number 2. I will change to 1 2 3. Yes, let's see 1 2 3, 1 4 5. Yeah, 1 4 5, and this is the result 2 6 8, right? That's correct. And then we can go to screen number 3. I will copy this one also. Yes, copy, and then go to screen number 3, and I will adjust this one to be like this, and then I will paste. Yes, like this. Maybe I will change this one to be black color, and for this one I will just change only PLC 3, this one PLC 3 also, and this one is PLC 3 also. Yes, and then we can simulation and test. After that we can download this screen to the real HMI. Yes, I will show step by step about how to download to the screen, and then we can control together. So this one for screen number 2, I will start the motor first and go to screen number 3. Screen number 3, this one, right? PLC 3. So I will set point to be 589. Yes, let's see, 589. This one 789. Let's see, 789. Okay, so it worked perfectly. Yes, screen 1, screen 2, and main screen. So we need to download this HMI project to the real HMI, right? And then test together. So before go to set the HMI, I would like to show the screen a little bit. Yes, don't forget this IP address of the HMI. So 192.168.20.4. Yes. So let's go to set the IP address of the HMI before we download the project of WinCC to the HMI. So let's go. Okay, this is the HMI. So when start up, let's go to bridge. Okay, when it start up first, let's go to control panel and then go to transfer. Make sure we put this one like this and then go to OK, and we need to go to Ethernet, yeah, and set the IP address. It's very important for IP address, otherwise we cannot download if we put the wrong IP address and we cannot connect from our PC, right? So for this one is 192.168.20.4, right? So I will set 192.168.2.20, right? Change to .20 and .4. Yes. And then please OK. Yes, OK one more time. And we check again to make sure the IP address that we put is keep here. It's OK. Yes. And then we can please transfer. Yes. And then let's go to our project of WinCC. Yes. So first we will close the simulation first. And then go to our project. Yes. Go to the main screen. Okay. And then we can ping the IP address. Sorry. Ping 192.168.20.4, right? So it shows like this. It means that we cannot communication with the HMI. Okay. So let me check the LAN cable. Yes. Of HMI connect to the switch properly or not. So wait a moment. we can type like this: AOP A AOP D 192.1 192.168.20.4, and then we try to ping again. Cannot ping, right? So let me check the LAN cable. Okay, right now I connect the LAN cable to the HMI, and then let's see here is can communication between HMI and our PC, right? So let's go to download. So we will put the IP address of HMI here, 192.168.20.4, right? And then please download. Let me show when it download the project. It will show the step also. Yeah. So let's click here. Yes. And then click here. It will transfer. Yes. Finish. Okay, right now finish download to the real HMI, and then we can also simulation. Yes, so we can see the status. I will zoom for PLC 2 like this. And then put the HMI here. Yes. And let's test the real HMI together. Yes. So let's see here the HMI. We already downloaded the program from the SIMATIC WinCC Flexible, right? So we can go to screen number 1. Yes, we will see like this. And then we can stop. We can start. Let's see the PLC is turned on and off also when we push stop, start. And for screen number 2, let's go to screen number 2. Yeah, please screen number 2. And then we can stop. Okay, let's see the condition of PLC. Start, stop, start, and then let's go to screen number 3. Yes, screen number 3 we can push stop, push start. Yes, and we can test for set point also. Yeah, example I will change this one to 5. Yeah, it will calculate to this step. Yes, so it worked perfectly between 3 PLC and only one HMI, right? So go to main screen like this. Yes. So this is just example about how to connect and control the PLC only one HMI to 3 PLC, right? So I hope everyone will follow my video step by step, because I already go slowly, yeah, too easy to understand. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Today I would like to show and share about how to link data between PLC S7-200 Smart CPU SR20 to PLC S7-200 Smart CPU SR20 by using the function put and get. So before go to create the program, I would like to explain the concept a little bit. Yes. So the concept is we would like to send the data from the PLC1 to PLC2 or send back from PLC2 to PLC1. We can link by the Profinet cable that connect together to the Ethernet switch, and then we can control from PC or touch screen. Okay, and in this section I will use step 7 microbit smart software and WinCC Flexible Smart version V3, and I will use the HMI Smart line 700 IE V3. Yes, then we can create the screen for control the PLC1 or control the PLC2, followed by LAN cable that connect to the switch. Okay, and I will assign the IP address to the PLC number 1 like 192.168.2.1, and for PLC number 2 192.168.2.2, and for my PC I will assign the IP address as 192.168.2.253, and for the HMI I also assign the IP 192.168.2.3. Okay, so if we go to our PC, we can ping from the PC to the PLC1 via this IP address, ping to the PLC2 via this IP address, and ping to the HMI by this IP address. Okay, so for easy to understand, I will go step by step and slowly for easy to understand and know the concept and test with the program. Yes, so let's go to next slide. I will explain more. Yes, for the next slide here we must use the wizard for get and put function. Example, if we would like to send the data from PLC1 with the transfer size in 2 byte, we can choose put. It means that put from PLC1 to PLC2, and PLC2 is 192.168.2.2. Okay, this one. So we will send from 192.168.2.1 to 192.168.2.2. Okay, then we send set like this. And for the memory, we can use another memory like VB, MB, etc. And this is the local address. For local address, it means that send from PLC1 the address of PLC1, and for the remote address is memory of PLC2. Okay, and then we can go to next and generate. We will got this block, and for this block it will check the time and cycle time and error. Then we can detect when, example, the network or LAN cable is loose. It will show the error, and then we can take this one to check when the error occur. It will reset the memory. Yes, then the network will cut. Okay, so go to next slide. For this slide I would like to show about the get memory from the remote CPU, 2 bytes also. Yeah, and then we choose the function get here. For this one we use put it means that put the some memory from PLC 1 to PLC 2, and for this one get it means that we get some memory from PLC 2 to PLC 1. Okay, and here is the remote IP address. It means that PLC 1, yes, this one. And the memory will start from V0 also, VB0, yes, and the concept is the same. So we will test together. Yes, so go to our software. So first let's go to step 7 MicroWin Smart software. Yes, open. And then if we follow our slide, we need to set up the wizard, right, by using the get and put function. So let's go to wizard here, and then we can use this one, double click, and we need to assign the name of the wizard name. Example, PLC1 data. Yes, so click next. So here if we would like to put the some memory from PLC 1 to PLC 2, we can select put. Yes, let's see, when we select, the arrow sign will change the position. Yeah, this one put, and this is the memory byte that we want. Example, I would like to send only 2 bytes. It means that 16 bits. Yes, and then here is the VB. It means that memory start from VB, example 0.0 until 1.7. Yes, 16 bit. We can also use IB, QB, MB, yeah, etc. So I will test with VB first. And here is the remote. It means that PLC2, yeah, PLC2. The IP address of PLC2 is 192.168.2.2, right? So we'll put the data from 192.168.2.1 to 192.168.2.2. Okay, and the memory will start from VB0 also. Yeah, and then go to next, and here is the suggest memory. So actually we can click suggest, it will automatically calculate for us, and then click next again, and then click generate. Yeah, after click generate, we will got one subroutine here. Yes, so we can drag and drop to the network, and then here is the timeout. Example, if we would like to read some help, please F1. Let's see what is the timeout. Yes, data type of timeout. Yeah, we can see cycle and error. We can read also. Yeah, so many instructions we can read and follow the manual operation of this software. It will work perfectly. Okay. So time I will set 2 seconds, and for cycle I will use some memory. Example M10.0, M10.1, and here we must put the always on, right? So we can use always on. Yes, and then we can compile. Okay, no error occur, and we need to create the logic for control from PLC 1 to PLC 2, right? So the logic, it will start from VB0, right? So example, I will send data from PLC 1 to PLC 2 from V0.0 to V1.7, right? 16-bit, 2 bytes. Yeah. And then we can copy the always on here. So it will start from V0.0, right? So example, I will use M0.0, start V0.0, yes, and then M0.1 will start V0.1, yes. Okay, and then we can save our project. So I will create one folder, put get PLC S7-200 Smart. Yeah, for this one is PLC 1, right? So PLC 1. Okay, and then we can go to create one more for PLC 2, get the data, right? So I will compile again. Yes, no error occur. And then we can create one more for PLC 2, got the data from the PLC 1, right? So first basically go to Visa tab and then go to get port, and here is the PLC 2 data, and then click next. So this one get, right? When get, let's see here, the arrow will go to this position, and when we select port, it will go to this direction. Okay, so right now PLC 2 is get, and then I will get 2 bytes also, right? So 2 bytes, and start from VB0 also. Yes, and here is the remote IP address of PLC, right? So 192.168.2.1, right? Remote, it means that the PLC that send the data. So PLC 1, and PLC 1 is 192.168.2.1. Okay, and for remote address, it will start from VB0 also. So click next, click suggest, click next, click generate. Okay, and then we can go to subroutine. Yeah, this one also. So always on. I will choose 2, and this one example M10.0, M10.1. Yes, and we need to compile the program. Yes, no error occur, and then we can create the command like get data from PLC1 v0.0 to v1.7. Okay, so I can copy the always on from the network 1. So this one should be command as network checking. Okay, so we will get the data from the PLC1. Yes, we will open the PLC1. Okay, open like this, easy to understand. Yes, so here is the PLC1. So I will send v0.0 to PLC2, right? So PLC2 will get we get 0 v0.0, right? So v0.0 example send to output u0.0. Yes, and v0.1 will send to output u0.1. Yes, then we can compile error 0. Yes, then save. So this one should be PLC2, right? Okay, so I will put PLC2. Okay, and we need to download this program to PLC1 and this program to PLC2, right? So first we need to put the computer IP address, yeah, the same as my slide that I already show here. So 192.168.2.253. Yes, otherwise we cannot ping, right? So we cannot ping 192.168.2.1. Okay, we cannot ping. One more, 192.168.2.2. yeah, we cannot ping also. Okay, if we cannot ping like this, we cannot download the program from our software to the PLC also, right? So we need to put the manual address of my PC here. So I will put 192.168.2.253. Yes, subnet mark 255.255.255.0. Then we will try to ping again. Yes, so we can ping for PLC1 and for PLC2 we can ping also. Yes, so it means that we can connect. So first we can download the program to the PLC number 1, right? So let me go to the communication here and then choose the correct adapter here. Yes, my network adapter. Okay, right now it detects two CPU. One is 192.168.1.2.1, right? And number two is 192.168.2.2. Yes, the PLC2. So right now I will download to PLC1, right? Because I write PLC1 here. So click on the PLC1 and then click OK. And then we can click download. Yes, download to PLC1, right? Stop the CPU. After that, we can go to run the CPU. Yes. And then we can online. Yes. Okay. Can online. So let's see, here is cycle memory. Yeah. Actually, we can take this bit to the HMI to show the cycle also. Yeah, let me show after this download complete. So right now we can go to download this program to the PLC2, right? So I will go to communication again. Go to find the CPU. Okay, and then I will select PLC2 192.168.2.2. Yes. Then I will download the program to PLC2. Then I will start the PLC2. Yes, and we can online. Yes. Let's see here the communication is okay. Let's see the cycle time is bling. Yes, it means that the communication is working properly. And for the error is 0, it means that no error, right? We can read from the health here. 0, it means that no error. Yes. Error, check instruction. Yes, code number. And we have also the code for error. Yes. So right now it's working. So let's test together. So if I write the M0.0 from here, V0.0 will turn on, and then the PLC2 will turn on also, right? Output will turn on because we already link. Let's see here. It work. I will turn on one more. It work. Yes. So the communication is work properly. Yes. And if we would like to stop, we can also write stop. Yeah. Write stop. Okay. And we can add more until bit number 0.v0.2 until v1.7, right? So let's add more for PLC number 1. Yes. M0.2 start v0.2 M0.3 start v0.3 M0.4 0.5 0.6 0.7 so this one will start the V0.3 M0.3 M0.4 V0.4 So this one M0.5, V0.5, M0.6, V0.6, M0.7, V0.7, and for the 8-bit more, right? So it will start from M1.0, control the V 1.0, .1, .2, .3, .4, .5, .6, .7, yes, and we can connect. So M.1, this one should be M.1, right? V 1.1, M1.2, V1.2, M1.3, V1.3, M1.4, V1.4, M1.5, V1.5, M1.6, V1.6, M1.7, V1.7, right? Okay, so totally 16 bits, yeah, 2 bytes. Then we can save the project and then download to the PLC. And we can online, yes. So for PLC 2, we also create, yeah, the same as the PLC 1, yeah. So I will outline first, and then we'll copy V0.2, control the output number 2, .3, control output number 3, yes. V 0.4, control the output 4, .5, control output 5, .6, control output number 6, one more, V0.7, control output number 7, right? Okay, it's just 8 bits. So the CPU SR20, it has only 8 bits for output. So we can use one more for %M. So example V1.0, it will start from M, right? Example M 1.0, yeah, I will start from M 1.0. Sorry, paste here. So V1.1, M1.1 .1.2 .3 .4 .5 .6 .7. Yes. Okay, so this one I can copy also. Okay, and then this one should be V1.2, right? This one V1 M1.2 V1.3 M1.3 V1.4 M1.4 .5 M1.5 V1.6 M1.6 V1.7 M1.7. Okay, so 16 bits also. Yes, then I can delete this. Yes, and we can save the project and then download to the PLC. After that, run, and we can online. Yes, so let's see PLC number 2 and number 1. Yes, I will put like this. And then if we would like to forward the signal, yes, okay, right on. Let's see, bit on, right on, this one on, right 2 on, this one on, the last bit. So we can go to the last also. Yes, yes, this one on. Okay, then we can create the safety example. Right now, if I take out one more cable of Ethernet cable, yeah, this one LAN cable, it will no action, right? Let me show. It will no action. It means that the output of this PLC is still on. Yes, no action if we disconnect the network. Actually, if we disconnect the network, it will have action, right? This output will turn off, right? I will test. Let's see here. I will disconnect the cable from this one. Disconnect the network cable. Yes. Let's see, the output of PLC 2 is still on, right? It's still on. So communication lost, but the output still on. So it's not correct, right? So we need to create the safety. Yes, if the network is cut, let's see. If I take out the network again, the communication will error, right? It will error the cycle time. Yes, it not have the cycle, right? Because lost communication. let's see, the error is occur. Change from 0 to 1, right? Because we already disconnect the cable, LAN cable from PLC 2, yes. But the output still on, the output of PLC 2, let me show. Let's see, the output of PLC 2 is still on, but the LAN cable I already disconnect from the LAN port, yes. So it doesn't correct. So to correct the function, if we take out the LAN cable or unplug the LAN cable, the output of PLC 2 will turn off, right? So we can go to the PLC 2, yes. Then we can create one more. I will insert this network. Okay, insert one more network. Okay, insert the network. So when M10.1 is turned on, it means that it one lost communication, right? So I will move by, right? Because we use the by memory, I will move 0 to VB0, right? And also move 0 to VB1, yes. Okay. And for the PLC 1, we can also modify, yes. So it lost the communication, yes. This one we can command when lost communication, then it will reset the value of data, right? So if M10.1 is turned on, then I will move 0 to this one, right? VB0. So VB0, and also move 0 to VB1. Okay. Then we can save and then download. Okay. PLC 1, and we will go to the PLC 2. Save and then download. Okay, and then we will test again. So now let's see the error is 0, it means that no error occur, right? So let me take out or unplug the LAN cable again, and then let's see the output of PLC2. It should be reset, right? Okay, so right now I will unplug the LAN cable from PLC1 again. Yes, let's see when I unplug, the output will is turned off, right? Okay, it means that lost communication between PLC1 and PLC2. Yes, so the output is turned off. Okay, so that's correct function. And we need to create the HMI for test, right? So let's go to HMI, WinCC Flexible Smart version 3. Create the empty project. Yes, and I will use Smart S7-200 IEV3. It is the HMI. Yes, my HMI. So I will choose this one. So first we need to create the connection, right? Okay, create the connection. Then we have two PLC that we want to control, right? Example PLC1 and choose the driver. I will connect to PLC S7-200 Smart. Yes, this one. And one more for PLC2, right? Okay. And between PLC1 and PLC2, we must choose the port that we want to connect from the HMI to PLC. So right now I will use Ethernet. So here is my IP address of my PC. So 192.168.2.253, right? And for the PLC1 is 192.168.2.1. Okay. And for PLC2, I will choose Ethernet also. And the IP address, my PC is the same, but the PLC is changed to 192.168.2.2. Yes. So that's okay. And then we need to create the text, right? We need to create the text. So to create the text, let's see here for PLC1. Yes. PLC1, it will start from M0.0 until M1.7, right? Okay. So we can go here. Example PLC1 M0.0. The driver is PLC1, right? and then the data type is Boolean, and start from M0.0. Yes, then we can draw like this. Delete this one. Yes, and one more for the V memory stator, right? V memory stator, it will start from V0.0 until V1.7, right? So PLC 1 V0.0. The driver is PLC 1 Boolean, and I will choose V 0.0. Yes, 0.0, and then we can drag like this. Yes, and for PLC 2 we also must create the text also. Yeah, it will start from V0.0 until V0.7. Yes, so PLC 2 V0.0, and this driver I will choose PLC 2, and it will start from V0.0. Okay, and then we can drag like this. Okay, and for PLC also we have the output, right? Start from Q0.0 until Q0.7, right? So PLC 2 Q0.0, the Boolean, and for the driver we choose PLC 2, data type is Boolean, start from Q0.0, then we can drag like this. Okay, delete one. Yes, that's all for create the text. Then we can go to the screen. Okay, we can save the project. I will put here, yes, this one, HMI put get. Okay, and then we can create the screen. Example, I can separate the part, two part, one part for PLC 1 and one more part for PLC 2, right? Okay, like this, and then I will increase, yeah, for separate the part. Okay, and then this one for PLC 1, right? Okay, I will choose text. So PLC 1 data, I will use bold, and I will increase the size. I will change the background to be this color, and for this one I will change to green. Okay, then we can copy for PLC 2. Yeah, PLC2 data. So we need to control from the PLC1 to PLC2 by using the M0.0 until M1.7, right? So I will create the button. Yes. Example, we can test only 4 or 5 bits. It's okay because it is the same. Yeah. Example, I will test only 4. Yes. Test only 4 bit. Okay. We can test only 4 bit first. For send the data from PLC 1 to 2, yeah, by controlled by HMI. So this one we can write bit 1, this one bit 2, this one example bit 15. This one should be bit 16. Yes, we can align. So I will change this button to be some color, example the blue color. Okay, this color or another color that we want, right? Okay, this color. And we need to see the status of this one also, right? Yeah, this one. So I will put lamp. Okay, this one for lamp 1. Then I will change to this color, and I will change the color animation when bit PLC1 V0.0 change, right? Okay, and I will change to green when the logic is 1. Yeah, it means that true. And then I will copy 3 more, and then we can align. Yes. Okay. And this one we can change the V0.1. This one we can change V1.6, right? V1.6 have or not? This one should be 1.6, right? V1.6. Let me check the text again. v1.6 PLC1 v1.6 not yet create, right? v1.6. Okay, then we can create PLC1 v1 1.0 PLC1 data, right? So v1.0 until v1.7, right? So drag. Okay, until v1.7. Okay, back, go to the screen again. So this one should be v1.6. Yes. And then this one should be v1.7, right? Okay. And for the PLC number 2, we can copy from here. Yes. So basically we can change only PLC 2, right? PLC 2 v1.6 not yet have, right? So I will create for PLC 2 v1.0. This one should be select for PLC 2. I would like to stick this one, yeah. Be careful when we select the driver. If we select the wrong driver, it means that we control the wrong HMI to PLC, right? So be careful in this step. So it will start from v1.0 until v1.7, right? Okay, v1.7. So back, go to the screen, and then this one should be PLC 2 v1.6, right? This one PLC 2 v1.7. Okay. So we can save the project and then we can simulation. Yes. Okay. When we simulation, let's see the bit is turned on here. Yes. So let me turn off. Okay, we can check the communication. I will offline first. And then check the communication. Let's check the PG-PC interface again. Okay, let close and then online again, and then we will simulation again. This one no action, right? Because we not yet config the button. Yes. Then we can go to config the button. Yes. Go to event, please, or we can click in the invert bit. Yes. Invert bit PLC1. Yes. PLC1 underscore M 0.0, right? This one. And for bit number 2, I will invert bit also. So PLC1 M 0.1. This one should be invert bit also. Invert bit M PLC1 M. Let me check the text again. Maybe not yet create, right? Okay, M 1.6 not yet create, right? So I will create the text first. So PLC1 M 1.0, right? This one should be selected for PLC1, and the boolean start from M 1.0. Okay. Okay, good. Back to the screen again. So this one should be PLC1 M 1.6, right? This one should be invert bit. So PLC1 M 1.7. Okay. Then we can save. Can simulation again. Okay. Then we can click here. Yes. Turn off. Turn off. Turn on. This one, right? This one. Turn on. Yes. Turn off. Turn on. Turn on. Turn on. Turn on. Yes. So we can simulation. Yes. From PLC1 to PLC2. And if we would like to send the data from PLC 2 to PLC1, we can also do it. Yeah, the same as the procedure. Yes. So this is just example about how to create the data from PLC by using the put and get function. Yes. So right now let me download the project to the HMI, yeah, to test on the HMI. So to download to the HMI, let me ping 192.168.2.3. Okay, we can ping, and then we can click here to download. Then we will choose this one and then put the IP address 192.168.2.3 to the HMI, right? And then we can download. Okay, finish. So we can simulation here and then we can go here to check. Actually we can use all of this bit, yes, but this is just example, so I test only 4 bits, yeah. So right now let's go to our HMI to test. Yes. Okay, right now I will push the button, yeah, here. Let's see. The output is turned off when I push. Yes. This one is off. Turn on. Turn on. Yes. So the communication between PLC 1 and PLC 2 is working properly. Okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon, and I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again, and see you next videos. Bye bye. Today I would like to show and share about how to link the PLC S7-200 Smart CPU SR30 with the TIA Portal version 17 by using the simulation for create the project HMI and link to the PLC. So before go to create the project, I would like to explain the concept of this connection. So first we need to have the LAN cable that connect from the LAN port of our computer to the Profinet port of PLC S7-200 Smart by using the LAN cable. And we need to have the software. The first one is Tab 7 Smart, and the second one we have TIA Portal other software, other version that we have. Then we can create the project in PLC and create the HMI screen for simulation, and then we can control from the HMI to the PLC. Okay. So let's go to our software to create the project of PLC and HMI screen, and then we can simulation together. So let's go. Okay, so I have installed in my PC as Step 7 MicroWin Smart version 2.5 and TIA Portal version 17. So first let's create the new folder for our project. Example test PLC Smart. Then we can open the software SIMATIC Step 7 MicroWin Smart to create the example project. So let's go to check the communication, find the CPUs. Okay, right now it detects one CPU that has IP address 192.168.20.2. Then we can put the manual IP address of our PC. Example, I will put 192.168.20.253 and subnet mask 255.255.255.0. And then click OK. So basically we can create the start stop one mirror. So I will choose M0.0 for stop from HMI. Yes. And I will choose M0.1 for start from the HMI. And then I will use output Q0.0 of PLC S7-200 Smart. And then we can find the symbol here. Yes, it is the I/O symbol. CPU input 0, I 0.0. And for the output, start from Q0.0. Then I will hold the signal of output Q0.0. Okay. And if we would like to start and stop from the I/O, it means that from the push button, we can also insert. I will insert column and then put the I 0.0 and create one more. I will change this one to I 0.1 for start and then hold the signal by Q 0.0. Yes, and then we can compile the program and save to the folder that we already created here. We can create a new folder or we can use this folder. PLC S7-200 Smart with TIA Portal version 17. Okay, and then we can download to PLC, stop the CPU and then start the CPU, and we can online. Yes. So right now, if I push the button start from the input of PLC, let's test. Okay, I will push button start. Let's see, the relay is turned on because the output Q0.0 is turned on. If I push stop, start again, it will start, and PLC is show the signal also. And then we can create the HMI project from TIA Portal for simulation, start and stop from the HMI. Yes. So first, let's open the TIA Portal. So wait a moment for create the project for TIA Portal. So we can go to create the new project and put the project name, example connect PLC S7-200 Smart, and then browse to folder that we already created on desktop. Yes, here, and then choose create one. The project will automatically create the object for us. And then go to project view and create the new device. And we can use HMI and then choose the touch panel that we would like to simulation. Right now I will use TP700 comfort and then choose OK. So wait a moment for create the new HMI. Yes, and then we can choose finish. And we will got the root screen like this. Yes, so this one we can delete. And first we need to create the connection for connect to PLC, right? So double click on connections and put the name of connection, example PLC Smart, and then choose the communication driver that we would like to connect. Right now we connect to PLC S7-200, right? So choose S7-200 and we will use the Ethernet because we use Profinet port, right? So Profinet port of PLC is 192.168.20.2. So we can put here 192.168.20.2. And for the IP address of our computer, we can check IP config. So 192.168.20.253. So we can put .20.253. And then we can go to HMI tech. Yes. So we need to create the text. The first one is stop, right? Stop. Let's see, stop from HMI is M0.0, right? M0.0, stop from HMI. So stop PB. The data type is Boolean. And we will use the PLC Smart. It is the connection that we already created. And then put the address, so M0.0. And here we can change 200 millisecond. And then we can create the start button. It is the M0.1. So start PB M0.1 and then cycle time we can use 100 millisecond. And we need to show the status of the relay 1 or motor 1, right? So Q0.0. So we will create motor 1 status. And then it will start from Q0.0. And we will change this one to 100 millisecond also. Then we can compile. So error 0, right? Then we can save. And we can go to our root screen. Basically we can delete and then put the title, example connect PLC S7-200 Smart CPU SR30 with TIA version 17. Then we can go to property to adjust the text size. We can uncheck the fit object, right? We can change the color that we want. I will change the field to be background. I will change to this color. And for this one, I will increase the size Okay, and then we can add the push button, right, for control from the HMI. So I will choose button stuff, increase the font size to be 29, go to property, general, I will change this one to be solid and change the color to be red. And for the corner, we can adjust to be bigger than this, yes, like this. And for the text button, I will change to black. Yes, and then we can copy for button start. So start, and then change this one to be blue color. Yes, so it should be like this. And then we can insert the motor. Example, I will use this motor. Okay, and then we need to show the status of the motor. Example, change from color red to white, red to green. So we need to configure the button, right? So right click, go to event, and then freeze. I will use set bit val key freeze, and then we can go to HMI text here. Then we can use like this. We can drag and drop. Example, push button stop. We can drag and drop the push button stop. I will go to root screen again. And then close this one first. Then we can freeze and choose the function set bit val key freeze, and then choose the text, example stuff PB. And for the start, we can go to event, freeze, and then choose set val key freeze, and then choose start. And for the motor status, we can go to animation, then go to display, add new animation, and choose apparent. And we need to show the motor status, right? Motor one status, and change from red to green color when the output is turned on. So we can save the project and then go to simulation. Yes. and then we can test the simulation here. So right now the motor is turned on because we just push the button from the input, right? So example, we would like to stop, we can press stop. Yes, the motor is stopped and relay is turned off. So if we would like to run, we can start from HMI. The motor is start, stop again, start and stop. Yes. So if we would like to start and stop another motor, example, we can go to test another motor. So we can write stop M2 M0.2 stop motor 2 M0.3 start motor 2, and then I will turn on one more output Q0.1 and then hold the signal also by Q0.1, and then we can compile and save the program and then download to the PLC, and we can online, and we will design the screen to start and stop the motor number 2, right? So let's go to our TIA portal, and I will arrange the push button and motor to be like this. Maybe we can adjust. Okay, and here we can copy and then write to be motor 1. And we can copy for motor number 2. Yes. We can select and then right click, copy, right click and paste. And change this one to be motor number 2. And we can copy and paste for motor number 2. Yes. And then we need to create the text, right? So we need to create M0.3, M0.2 for stop, M0.3 for start, Q0.1 for status of the motor number 2. So let's go to text. So this one should be stop motor 2. The data type is Boolean. We use PLC connection and then start from M0.2 100 millisec, and then start motor 2. So M0.3 and cycle time 100 millisec also. And the next we will create the motor 2 status, and we will use Q 0.1, and then choose 100 millisec also, and we can compile, save and compile. Okay, compile start with no error, and then we can go to root screen and then go to stop button and then choose the event, and then change this one to stop motor 2, and for this one event start motor 2, and for this one we can change to be motor 2 status, right? So that's all, and then we can compile, and then pre-simulation to start simulation with 2 motors. Okay, so here we can online and then check for both motor. We have motor 1 and 2, right? And then we have HMI. So we can start motor 1. Yes, motor 1 is running. So motor 2, yes, it's running also. And the PLC is turned on. Okay, I will show the status on PLC when we push the button from the HMI. Okay, so let's see, the PLC is turned on. So if I push stop, example I stop button motor number 2, it stop. Stop motor number 1, it stop. Start again, it turn on again. Okay. So communication between PLC S7-200 Smart and HMI simulation is perfectly. Yes. So if we would like to count the speed motor, example, we will create one more. I will insert network here. Sorry. Okay. So if output is turned on, I will add and then choose the SM0.4, right? SM0.5, clock 1 second, and then add real. Example, I will add 1.1.25 to MD 10. Okay, like this. And if the output is turned off, I will move 0. So if Q0.0 is turned off, I will move 0.0 to MD 10. Okay, the same as motor number 2. If motor number 2 is turned on, so Q0.1 is turned on, then I will add real. Example, I will add 1.55 to MD20. Yes, just example. And here I will insert column. So I will use clock path memory. So MSM 0.5, and then I will use positive edge. And if the motor is turned off, so Q0.1 is turned off, then I will move real 0.0 to MD20. Okay, save the project, compile the project, and then download to the PLC. Okay, so clock path memory is working right now. So wait only motor run, and then it will increase the value to MD10, and then we will show on the TIA portal. So we need to create the text. So I will use the motor 1 speed. It is the real, right? MD10. I will use cycle 100 millisecond also, and one more for motor 2 speed. It is the real also, and MD20. Here MD20. For speed motor number 2, yes, 100 millisecond. Save and compile the project, and then go to root screen, and then we can choose basically we can choose this one. So I will show the motor speed here. Go to property, go to general, and choose the text motor 1 speed, and then we can choose like this. Choose this format, go to layout, then go to text format. I will change this text format to be center, this one to middle, and go to apparent, change the color to be black, and then text color to be green, and then change this one to be white, decrease this one, yes, and change the text to be 21, and for the unit is RPM, right? So this one should be RPM. I will change to white color. Okay, and then we can copy for motor number 2. So copy and then paste. Okay, and then change the general to be motor number 2 speed. Okay, good. And we can save and then simulation, yes. So when the button start was pressed, and then the value will increase, right? So I will start. This one increase, right? So let's check the MD20 again. Why not show? MD20. Oh, this one should be NC, right? I will change to NC, because when the motor is not run, the motor 2 is not run, it should be so 0 to MD20, right? So I will download again, and then we can go online. I will zoom in a little bit. Okay, and then we can simulation again. So I will push start, and then the speed, the motor will increase. Yes. If I push stop, it will 0. Stop, it will 0. Start again, it will up speed again. Yes, because we generate with the automatically add. So the speed motor will increase. Yes. So this is just a sample about how to link the TIA Portal version 17 with PLC S7-200 Smart by using the simulation. Yes. And we can also simulation to be real PLC also. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye.